Oh, do you hear me? Okay, everyone, I don't know if you hear me. Please come here. We are starting, so... okay. You are the first ones. You are the most excited. That wasn't sound like, yay. It was more like, yeah, I want to hear, yeah. Thank you, thank you. Okay, I'm thinking if we should give them more time or just start. I think we waited for enough time. So, hello everyone. It's excited to see you all here. I'm really happy to see you here. I would probably start like I'm Clary. I'm one of the organizers. I'm from Polkadot, which is NFT marketplace. And I'm taking care of the marketing, social media, events, and all stuff around. We are super excited to have you all here in this beautiful city in Industra. And today we will hear from several speakers from Polkadot and Kusama ecosystem. And we will have a lot of opportunity to connect, network, and find new relationships. I would like to thank you to all organizers, which is Polkadot, Apelon, and Polkadoters, because we wouldn't be here without them today or without us. I think we need to start with a little bit of housekeeping before we start it. So the restrooms are just over there on the right side when you will be leaving this place. Just in front you will find the changing room where you can leave your bag, where you can leave your jacket, and you will also get the merch there. We are gonna have 3 breaks in total. One will be at 1. The other one is gonna be at 3, which is gonna be for 1 hour. So you will have enough time to connect, to talk, to see the NFT gallery, and have some food, of course. And then we will have 1 more break at 5 before panel discussion. I would love to just ask you to wear the tag with your name, so staff knows you are from the conference, and you can have drinks and coffee and everything for free, because they have the coffee open, so even some random people will be passing here. So yeah, I would like to also mention that on our Twitter, there is already a link for after party. So if you are considering or if you would like to go, just claim your ticket, because there is a capacity, so be sure if you want to come to have ticket. And then also like a bonus, upstairs there is, I don't know, gallery. Don't ask me what is it. You can just have a look and then tell me, because I didn't find out. And now let's get into, shall we? So the first speaker, oh, no. First, I want to hear some applause, guys. You are dead. Give me applause, yeah. Okay, that's better. I feel much better now. Today we're gonna have a first speaker who's gonna open DOTBrno Conference, and it's gonna be Zixi. She's, yeah, applause for her. Zixi is a business development associate at Interlay, and she will be speaking to us today about Bitcoin, finance, and banks. So please, one more time, applause for her.
Hello. Hi, everybody. Nice meeting you all. I'm very happy to be here in this very beautiful city of Brno, and thank you very much for the organizers of Brno Dot for hosting this amazing event. Today, actually, my colleague Danilo is supposed to be here and do this speech, but very sadly, he got sick and cannot be here, so I am here filling his spot. My name is Zixi. I work for the business development team at Interlay. So today, we're going to talk about Bitcoin, and I will also talk to you about the next step for Interlay. In the next 6 months, we're building Interlay 2.0. I know a lot of you here is already engaged in our community, and probably a lot of you have tried our product. And today, I'm going to bring the news and talk about what we're doing next. So Bitcoin in DeFi, that's what we do. Interlay in 3 words, decentralized finance for Bitcoin. I want to start by asking the audience here, how many of you owns Bitcoin? If you can show your hand. Beautiful. And how many of you have money or involved in anything to do with DeFi? Beautiful. And how many of you here is earning money from Bitcoin in DeFi? Amazing. I love that. I love that. Yeah, not so much. So we can see almost everybody here have Bitcoin. Almost everybody here use DeFi. But there's only 3 hands for Bitcoin in DeFi. Bitcoin was born out of a crisis. The existence of Bitcoin was a revolution. Was a revolution. So Bitcoin gives an opportunity for people to store value without trusting traditional financial institutions. Bitcoin gives us hope to do transaction in a new way that is instant, global, anonymous, and decentralized. But however, if I own Bitcoin and I want to use it nowadays to earn, to do anything, the tools that we have doesn't really reflect this value. The tools that we have now mostly exist on centralized exchanges or centralized bridges. So as part of our, as part of our mission at Interlay, we want to fully explore the potential of BTC in 2 ways. First, we want to make products that can restore the true core nature of Bitcoin. And second, we want to expand the use cases in DeFi, allow people to do more with their BTC and earn more with their BTC. Solution, one dApp for all things Bitcoin finance. Right now at Interlay, what we have is a trustless bridge. We solve 2 problems with DeFi. First is the centralization. And we want to build something that's fully decentralized. And second, adoption. The technical nature of Bitcoin is limiting. Bitcoin was designed for payment. It was not like Ethereum. It's not designed for programmability. So there's a lot of times when you want to use Bitcoin, you notice it's hard to move between blockchains. And this is also part of the reason why we choose to be on Polkadot, because part of Polkadot's nature is the interoperability. If we look at the market, 395 billion market cap for Bitcoin, only 10% of that exists in DeFi. And out of that number, nearly 60% lives on Ethereum. With Ethereum, the common product that we know for wrapped BTC, like WBTC, RenBTC, we will talk about it later, is not really decentralized in its core. So what does it leave us? It leaves us less than 10 million true Bitcoin in DeFi TVL. There's a lot of companies out there that is making wrapped BTC products to allow users use their Bitcoin in very creative ways, use it in different blockchain, but we achieve different goals. If you look at this graph here, the vertical would be the interoperability between blockchain, multi-chain capability, and horizontally is the trustlessness, also decentralization. Some of the popular player, WBTC, HBTC here. The way that you get, for example, a WBTC, similar to InterBTC, which is what we have, is you put your Bitcoin to a facility, and then you mint WBTC. But the thing is, with WBTC, you have to go to a merchant. And this merchant is a trusted, high-value institutional facility. For example, one of the famous example for WBTC merchant, Alameda Research. You trust them, you get your WBTC, use it in Ethereum, earn yield, and then you come back. This whole process, you trust the bridge, you trust Ethereum blockchain, you trust your wallet, and at the end, you will have to trust that when you bring back your Bitcoin to redeem, they still have it. They have your Bitcoin and they're willing to give it back to you. However, with the true nature of Bitcoin, you're not supposed to have to trust one person or a group of people. That's why we try to come to the very right side of this graph. And we have some other companies who is also labeling themselves on this side of the graph. For example, the TBTC, which was made by Keep. There are some other, and also I would say including the real Bitcoin itself, it's also very decentralized on this side, but there's not much that you can do there. There's not much use cases. You cannot transfer it easily between blockchains. There's not so much earning opportunities. Most of the time, your Bitcoin just sit in your wallet and you wait for the market to go up. So Interlay, after 1 year of building, we have a trustless bridge that is up and running now. Our next step is to become a DeFi hub where it expand the way that you people can use their Bitcoin and earn. So when we talk about trustless, what does it mean? For us, trustless means two things. First, non-custodian. Second, insurance. When it comes to the issue of custody, very sensitive words in crypto, would you trust to keep your money in a financial institution or a decentralized network? The thing that makes us truly trustless and decentralized is our unique system of vault. And I know some of our audience here is actually in our vault. Thank you very much. Vault, anybody can be a vault. You don't have to be a multi-million company to be a merchant of InterBTC. As long as you have the hardware, you have the amount of collateral asset, you can register and be a vault. There is no KYC, there's no nothing. But how do we make sure this whole process is reliable? As a vault, you set up the hardware, you set up the software, and you bring collateral asset. You over-collateralize your vault with 260% in DOT. And by the way, we're expanding the collateral asset that we will accept. We're researching into more and more assets, including like USDT, USDC, popular assets that our community want to see and make it possible for more people to use their assets to open up a vault. And your responsibility will be processing requests, very similar to what staking providers do on POS system, validating. As a user, I bring my BTC to Interlay. I put it in the bridge, and I mint IBTC. After I use my IBTC, I want to go back and claim my Bitcoin. This time, you go to the website, you say, I want to take my BTC out. If the vault that was looking after your Bitcoin was honest, they're responsible, they fulfill your redeem request, you get your money back. But if they're not honest, they misbehave, or somehow they made a mistake, what happened, and they cannot provide you with your BTC, they will be punished, they will be liquidated, and you will receive the same amount of value and more in collateral asset. So we designed the system in a way where we incentivize our vault network to act honestly. And when we come back to the second point of Bitcoin problem that we have, which is adoption, the technical difficulty for Bitcoin to be adapted into more ecosystem in more use cases, this is our next solution, which is the one-stop shop for Bitcoin finance. In 3 months from now, we will see the Kintsugi 2.0 live, the super app on Kintsugi on Kusama. In 6 months from now, we'll see the Interlay 2.0 live on Polkadot. More than just being a bridge, we will provide users with one-click interface where you can just invest and start earning passive income with one click. We will start we are actually in the process of building an automated market maker for traders. At the same time, we're also developing a lending and borrowing protocol for more risk-averse users. We're developing features for investors of all different appetite, for users with different risk levels. We want to make DeFi for Bitcoin accessible for everybody. And something else to mention, fiat on-ramp and off-ramp. I'm sure everybody here have this experience. When you want to do something in DeFi, it might be difficult because you have to open 10 different websites. I first register for a wallet, I go to an exchange, I buy the asset, transfer to wallet, bridge it to somewhere else, and then open another interface, blah, blah. And then after all, I lose track of what's happening. It's difficult. It's complicated. I don't remember everything that happened. We want to make this possible for people who are not expert in DeFi. Everybody should be able to use their Bitcoin. Everybody should be able to be in DeFi. That's why we will use fiat, on-ramp, and off-ramp, make people possible to purchase directly inter-token, purchase directly assets, Bitcoin, that they want in our website. And after they lend or borrow or they do whatever action they want to do, they will be easily offboarding their crypto back into fiat money in their bank account if they want to. Do we have any question up to this point? Or maybe I think we'll leave the FAQ to the end. But going on to our business model, this is how we make money as a company. This is also how our vault make money as part of our network, and also for Intertoken, who holds our native token. Right now, currently, IBTC bridge fee is the main income for every transaction that happens on Interlay. 0.5% goes to our network. It's distributed among our vaults, among our inter-token holders, and other stakeholders. When our new features come live, lending fee will be a part. You will receive an inter. AMM fee will become a part of your income coming from whatever the asset that you're trading. Cross-chain routing fee coming from our interaction, the assets movement between parachains, and hopefully in the future between different blockchains, even outside of Polkadot system. Interlay, as I may be repeating myself, Kintsugi been live since March, Interlay live since July. We have over 50 community members, over 3 million BTC bridge volume, cross-chain volume 68.9 BTC on Interlay, and over 102 BTC on Kintsugi. We have over 300 users daily, and more people signing up and coming to mint IBTC every day. Going into our roadmap, this is us today. We have the first fully decentralized Bitcoin bridge on the market. In 3 months, you will see a one-stop shop DeFi for Bitcoin, Interlake 2.0. Next year, we want to expand outside of our home of Polkadot. We want to start interacting with other blockchains like Cosmos, Avalanche, Ethereum. And in the very near future, we aim to bring it to retail investors, expand the use cases, invite people from Web 2 to Web 3, invite people who hold their savings in fiat into putting it into a Bitcoin account. When it comes to custody solutions, right now we have a network of Vault, realizing the decentralized nature, but still, you have to move your Bitcoin. In the future, our dream is to develop a product where your Bitcoin stay in your wallet, and when you lend, you borrow, it requires very minimum or almost no collateral, and you can just earn Bitcoin when you're holding your key, holding your coins. Where all this come from, I have to give a shout out to our 2 founders, Alexei and Dom. They studied together in Imperial College London, and they did their PhD on Bitcoin and on the cross-chain possibility of blockchain. And you can find their paper, their research paper on our website. It's really worth a read if you want to get deeper. And another big shout out to all of our partners in the ecosystem. This is all the partners that we have on the map right now. But we're looking to expand more. We want to collaborate more. We want more and more people, more and more assets on our platform. We want to work with you. So I will be very happy to talk to you for anybody who is here. If you have any amazing ideas, if you want to be a part of the Interlake network, we can explore together. And I think that's it for my presentation for today, and thank you very much. I'm happy to take any questions if we have time. Yeah, thank you.
I mean, I just have to say, the opening, I think we should mention this, because it was so nice how you asked us, like, do you have a Bitcoin? And all of us were like, oh yeah. And then she was like, and do you make money? And we were like, oh no. It was like incredible. I mean, I really can't wait if Interlake succeeds or when they succeed. I think it will be time-changing for the whole ecosystem, and I just wish you good luck. Really thank you for the presentation, for your time, and one more time, applause for Zixi. Thank you. Okay, so let's move to the next talk. And we will have for the second talk, Matt C. from DOTBrno. So please, come on the stage. Some sound for him, please. Matt works as a community leader in DOTBrno, and he's going to be talking to us about the dark horse of Polkadot stablecoins. So I know he's not female, guys, but don't be, give him some better applause, I know it's better to look at like females and women's, but be nice.
Okay, so GM everyone here and also on the stream. I'm glad that you came into Brno on another DOTSama event. and where you can basically hear a lot of informations from the ecosystem and also possible networking and connecting with the other people. Anyway, I'm Matt, community lead of DAO, where I'm mainly responsible to managing our socials, creating content, reviewing content, and I'm also the head of our ambassador program. So what is actually DAO? We are creating stablecoin. So DAO is a decentralized money market and multi-collateral stablecoin built on Astar network and for Polkadot ecosystem, which allows user to borrow buy our stablecoin, which is hard pegged to $1 against their assets with 0% interest and minimum collateral ratio. Basically, I think that you are familiar with other CDPs already established and well known as Liquidity and MakerDAO. So basically, we took the best parts from them, implement and connect to our protocol, and also create new unique features to ourselves. So these are benefits which I just name it, like higher capital efficiency via instant liquidation, which means that the price, ensure the price will never goes above $1.02. High price stability via instant redemption and stablecoin collaterals, which ensure downside action, so we never fall much beyond $1. More protocol revenue by utilizing protocol control liquidity in AMA. This feature is not ready yet, but in early next year it will be implemented. I will be talking in next slide. Multi-collateral support and interest-free loan to benefit loyal yield farmers. V-tokenomics to empower protocol tokens, and adjustable parameters via DAO governance, since DAO governance is kind of crucial because from recent actions and hacks, we need to act quickly and for example, just freeze contracts to not lose users' money, because security for our users is our priority. So let's take a look on high capital efficiency. So basically, stability pool and instant liquidations ensure that the total supply of buy is always backed by assets, over collateralized. So basically, when any vault is liquidated, the debt is burned into stability pool, and the collateral goes to stability pool too, and it's distributed among the stability providers, which are staking buy into the stability pool and gaining these liquidation, let's say, collaterals, and also liquidity mining in our proto token ATIT. Instant liquidation means that we are not part of any auctions, and the vault is liquidated immediately. We have different minimum collateral ratios. So for example, Astar, it's like 130%. For stablecoins, it's like 1.02%. So quite low, and yeah, that's okay. So next slide is high price stability, hard pegging via redemption and stability collaterals. So basically, this one is to creating a price floor for buy that never goes to beyond $1, and the redemption process is exchanging buy for collateral. So this becomes handy, especially when the buy is depegged down. So the redeemers can initially redeem and redeem collaterals which has lowest collateral ratio, and that means that the vaults they doesn't have to be close to minimum collateral ratio. It has to be 200%. But if you are the lowest vault with that, the redeemers can take a chance and arbitrage themselves and gain profit. So high protocol revenue embeds stablecoin automat market maker. In the long-term plan, as we want to implement it because right now in stability pool we got only our stablecoin buy, but in the future, early next year, we want to implement the automat market maker with a lot of other stablecoins. For example, DAI, BUSD, and other biggest stablecoins. So this creates the automat market maker, and basically this means that the stability providers will share the revenue from the collaterals, earn liquidity mining for ATIT, and also they can gain some fees from the exchanges in automat market maker. And this one is just a far future idea which disconnects the real world with our contract. So we want to do a DeFi lending around the buy, introducing real world asset income opportunities on the chain and opening up new cases for buy. DeFi lending DAO, where people deposit buy, convert to USDC, for an example, through AMM, convert into USD, and lend it to offline entities in pursuit of high return than DeFi. We believe this bring real-world revenue opportunities onto the chain, could be a future trend. Therefore, we will explore this after Astrid Volume 2, but it's idea, and we need some confirmation for that to be implemented. So basically, I was talking about DAO governance. The main thing here, we need to be quick, especially in this time. So let's suppose the collateral ratio of some asset is a little bit off. People are getting liquidated. So DAO governance can make a proposal to get a bigger MCR, minimum collateral ratio, and instantly just after vote we can put it in different number. Also, emergency handling, this one on the attacks and breaches, which are most common, especially in this year. So, as I said, DAO can vote to freeze contracts to protect fund losses. And last thing, we can have some improvement plans. So we can vote which collateral will be next to add revenue percentage or some other improvements and security enchantments. So these are kind of general by use cases. Basically, right now we are a little bit limited since XCM are not completed from our start to other section, and we are just waiting for opening our HRMP channels, sorry. And we are free to go because buy is ready and interoperable. But right now, we are just limited to Astar network. So basically, you can stake or put buy into stability pool and earn collaterals plus liquidity mining. You can use liquidity providers like RSwap, Zenlink, Kagla. You can put buy as collateral in some lending protocol, or also you can be yield farmer on Vault and Alnar. So this is diagram how our contracts work. So basically here you can see borrowers when it's all star. Borrower will borrow buy. Here's an example as Aster. If it's under collateralized, stability pool initiated liquidation. If you are a stability provider, you are depositing buy. and your collateral and ate it. Also, the next one, you can be liquidation initiators. We have in our front end that you can initiate the liquidation when you see some vault that is close to minimum collateral ratio. You are reporting and you are getting rewards for that too. Last thing, redeemers, as I said, they are basically waiting when buy is depegged down, and they are redeeming vaults with lowest collateral ratio and earn their collateral in full, but they are gaining like more in dollar value, so it's worth it. And last thing here, price oracles. Right now we are using DIA oracles, band protocol, and we are talking with Alchemy too. So we want to be sure that the oracle's price is working well, since there can be some problems with the price, and after that, user can be liquidated from the third party. So, as I say, what's next is we are close to be fully interoperable with BUY to other parachains, which means more issuance, more use case for BUY, and our protocol ate it. And right now, this is the roadmap right now. The XCM support to contract more parachains. We are going in weeks, I hope like 2 weeks, on Fala network, when we will be like, I think, the dominant stablecoin too, which creates possibilities to mint more BUY, more issuance. We are also with Litentry, Clover, and Moonbeam kind of close. So I think after Astar putting this, or it's already voted, but the devs have to finalize the last steps, and we will be on the other parachains. Also, we are working with SIO2 lending protocol, which is also from us. Basically, we will create synergies like that we can use S tokens to our Astrid DAO, and BUY is already there in SIO2, which means also, like, I remember SIO2 is already implementing Interlace IBTC, which is really important for us, because right now we want to have more native assets as collaterals, since the bridged assets is kind of, what do I say, danger zone. So right now we are looking for a more native asset like IBTC, Kusama, or Fala. This one, like, these are some kind of achievements. We got peaked at 50 million total value locked before the Luna crash. So right now it's like 7 million, maybe less, since recent actions also doesn't help. And we are really honored that we are part of Microsoft startup program, which also helps us to be like beyond people more aware of us. Yeah, these are some partners, especially like the VCs, but I would say that we are proud that we are audited by Certic, Slowmist, and PackShield. I think all the contracts are audited, so that's all. Okay, so thank you. I'm glad to be here, and have a nice day.
Does anyone have some questions for Matt before we will let him go? Okay. I would also love to mention that Matt is working in Astar as well, right? So I'm not really sure if we have someone represented here today, but if you would like to ask more questions even about Astar, here he is for you. So thank you for your talk. Okay, so we are going to our third talk. After this talk, we will have a first break. And I would like to invite on the stage Torsten Stuber, the CTO of Pendulum. So applause for him, please. And he's gonna explain us how space will connect Polkadot and the Stellar ecosystem if he's not gonna kill himself before. Are you ready? So please, one more applause for him.
Thank you. Can you guys hear me? Yeah. Almost fell off the stage here, so I hope this doesn't happen again. So hello everyone. I went to Rome recently. How does it work? Oh, the down button. Okay. I went to Rome recently, and I passed by an exchange office, a currency exchange office at the airport. And when I saw it, I was shocked. So I looked at these prices, and what you see is that the spread is really massive. So for example, let's look at the Japanese yen. Unfortunately, it's a little bit blurry, but I hope you can see it. Let's look at Japanese yen. And if you want to provide Japanese yen for €1, you need to give 167 yen to the office. But if you want to exchange a euro back to yen, you only get 128 yens. And if you look at the other currencies, you see similar relationships, really massive spread, and almost feels like a rip-off, in my opinion. I think all of you guys already were in a similar situation, so you really can relate to this. And I really wonder, when I saw this, why in traditional finance, the forex market, the foreign exchange market, is has still these ridiculous fees, is still so intransparent, because you don't know who's actually in the background, who takes your fees, and so on. And I thought the answer, and I think you also agree, the answer is blockchain. The answer is stablecoins, and the answer is forex markets on blockchain. And that's precisely what our project Pendulum is going to address. Hello everyone, I'm the CTO of Pendulum, I'm Torsten, and let me first give you some background about our project. So Pendulum itself is a parachain project on Polkadot. We are not live yet, but our goal is to be live at the beginning of next year. However, we are already live on Kusama with our parachain called Amplitude. So Amplitude is basically the same, but on Kusama. Our mission is to connect DeFi networks to the connect fiat networks to the DeFi ecosystem. And what that means is that our goal is to become the central hub for fiat coins and stable tokens. To be more specific, we also tailor our blockchain for Forex. That means that if you intend to build an application for Forex, we provide the ideal ecosystem for you. In addition to this, something is also special for us and important is that we are going to integrate or build integration for local banks. And what that means is what I want to show you on this next slide. This is an example of a currency transfer or cross-border transfer from Europe to Tanzania. So I want to pay someone in Tanzania. I start with euros and want that my recipient in Tanzania receives Tanzanian shilling, which is the local currency in Tanzania. And now if you want to do this with Pendulum, then Pendulum uses local banking and fintech integrations in both Europe and Tanzania to tokenize euros and to de-tokenize a Tanzanian shilling in the target region. So the only missing component is then happening in Pendulum, where you need to exchange those tokens. You need to exchange a euro token to a Tanzanian shilling token before you can de-tokenize the Tanzanian shilling token in Tanzania. And in order to do this, we use the power of a Forex automated market maker. And the Forex automated market maker is an automated market maker that's optimized for Forex. That means that you have single-sided liquidity pools, which is optimized for this, or price curves that are optimized for Forex, or also a backstop pool based, for example, on USDC. Now, it becomes apparent that local banking integrations are very important for us, but I also said that Pendulum is all about stablecoins, the central hub for stablecoins. In order to get there, we also want to bring in all kinds of stablecoins from other blockchain ecosystems. So we look at many different blockchain ecosystems that have a great support for stablecoins and build bridges to them. And we have been looking at a lot of these ecosystems in the last couple of months and years, actually. And when we studied those blockchains and how to build bridges to them, it became apparent that all these different blockchains use very different technologies, and with different technologies you also need to build many different bridges. And just building one bridge is already complicated enough. So for that reason, we came up with the concept of spacewalk. That's our abstract concept for building bridges in a unified manner that are optimized for stablecoins and that are bridges for, particularly for Polkadot parachains. And with building this bridge, building the spacewalk bridge, we make it possible to not just bring in stablecoins to Pendulum, but also make them available to the whole parachain ecosystem on Polkadot, and of course also Kusama, because you have built-in bridges on Polkadot anyway. So once the tokens are there, everyone can use them on Polkadot. Now I think it became apparent what's important for us. First, we have local banking integrations. Then we have the spacewalk bridge as a really fundamental concept for bringing in stablecoins, and we have different kinds of Forex AMMs. And this is just something I want to focus on, but there are of course also other aspects that are really important for Pendulum. Basically every stablecoin DeFi application you can think of is a valid use case for Pendulum. But here in this presentation, I want to particularly focus on the spacewalk bridge and on Forex AMMs. So let me start with the spacewalk bridge. I already said that spacewalk is a unified bridge concept for .sama, but to be more technical, it's actually a bridge concept for substrate-based chains. So for all kind of parachains, for example. I want to point out that spacewalk itself is not just a concept, but it's also a concrete implementation. It is an implementation that's rewarded with a Web3 grant, and of course, we are going to use this implementation on Pendulum, but it's actually totally independent of Pendulum. It resides in its own repository. Every parachain can actually use it for their own purposes, not just Pendulum. And if you want to use it on your parachain, you basically just plug in a pallet. As you're familiar with substrate chains, they have these components called pallets. You can just plug in the spacewalk pallet on your parachain. In addition to this, you also need to run a couple of services, for example, some kind of oracles, or some kind of custodian services. Really depends on what kind of concrete bridge you're actually going to use to what blockchain. Now let me talk about the main features for spacewalk. When we developed spacewalk, we had 3 criteria in mind that are really important for us. The first one is that it truly has to be decentralized. We studied a lot of different bridge concepts, and of course the older bridge concepts are very centralized, but also some other bridges claim to be decentralized, although they don't really meet our standard of decentralization. And unfortunately this year there were like so many really high value attacks on bridges. It started with a big attack in March where someone stole, I forgot the name of the bridge, but someone stole $600 million from a single bridge, and this just happened because the bridge was not really decentralized. So decentralization really matters if you want to have a secure bridge. In addition to this, spacewalk is trust minimized. That means that if you have to interact with a human actor, then that human actor will be economically incentivized not to misbehave. Or if they misbehave, then at least you're guaranteed to get your money back as a user. Thirdly, spacewalk is censorship resistant. That means, again, if you have to interact with the human actor, that human actor could deny service to you, but you can always go to another provider in that decentralized network, or you can provide your own service in that network, and at the end, spacewalk always guarantees service to you. Now, after this let me point out again that spacewalk is a decentralized concept that's unified, and if you want to use spacewalk in your bridge, then you have different components to these different blockchains that you want to bridge to, but the API layer to your own network is really unified with the unified API. Now, after this very theoretical presentation of spacewalk, I want to look at one particular instance, which is a bridge to Stellar, another blockchain. And that particular instance is very interesting for us at Pendulum because Stellar has a really great supply of stablecoins. I'm talking about fiat-backed stablecoins that are 100% collateralized with fiat and that are compliant and that are not something like algorithmic stablecoins that made really bad news this year. So this is something we can rely on. And what's also really interesting for Stellar is that they have local banking integrations to get those coins on their chain, and they have stablecoins from many different countries, for example, Brazilian reais, Nigerian naira, Mexican pesos, and so on. So this is a very interesting use case for Pendulum, as I said, for the central hub for stablecoins. Of course, we want to have them on our network. Now, this network, this bridge to Stellar is very interesting. First, Stellar doesn't support smart contracts, and this is actually very similar to Bitcoin, which doesn't have smart contracts. And for that one reason, Spacewalk for Stellar is actually built on that really great concept of the inter-BTC bridge. We already heard about this morning. Inter-BTC is really a great concept, peer-reviewed research, really decentralized. I don't need to repeat this again, you already learned about this today. But it's really something that we want to build on, but there are of course some very crucial differences because we don't bridge to Bitcoin, but we bridge to Stellar. And one main concept, one main difference is the Stellar Oracle that you see here in the middle. But before I go to talk about the Stellar Oracle, let me first talk about this general diagram. Bear with me, there are different components here, I will go through them one by one. First, we have two blockchains. And these are the orange boxes that you see here. So on the one hand, you have the Stellar blockchain, and on the other side, you have a substrate chain, for example, Pendulum. Now, if you want to bridge a token from Stellar to the substrate chain, then you cannot actually move that over. What you do instead, that you simulate that move. That's what a bridge does. The bridge simulates that a token goes from one chain to another chain. And this simulation basically always works in similar ways. So what you do is that if you want to send a token from this account on the Stellar chain to an account on the substrate chain, then you lock that token in special accounts on the Stellar side, and those accounts are called vaults, like on inter-BTC. And as long as the coins are locked in those vaults, they are rendered unusable on Stellar. And as long as this is the case, you can then mint a copy of that coin on the substrate side. And this copy is called a wrap token, as you know. Now, because Stellar doesn't allow for smart contracts, those vaults are operated by human actors and not by smart contracts. Smart contracts would be reliable because you can study that they behave the way you intend. Human actors can run away with the money. And for that reason, the human actors are incentivized not to misbehave through collaterals. It's very similar like an inter-BTC, again. A great concept, and that really works to disincentivize misbehavior. In addition to this, you also have a price oracle on the substrate side. This price oracle is required in order to value the value of the locked tokens inside the vault against the value that's inside the collateral, that's locked in the collateral. And you need this price feed oracle because the tokens that are locked on the Stellar side and the tokens that you use in the collateral are usually different. Let's say you have a USDC coin that you want to bridge, then the USDC coin is locked in the vault, but as a collateral would probably use the Polkadot native coin. And now if you see that the collateral is not enough anymore to cover the cost of the vaults or to cover that value, then you need to liquidate the vault and the user will get their money back. So far, it's very similar to inter-BTC. Now the main component that's different is the Stellar Oracle. That's a very crucial component because it's a component that tells the substrate side, the pallet on the substrate side, what actually happens on Stellar side. And this is of course something that you need in a bridge. It's, for example, important if someone wants to send tokens from Stellar to substrate and locks those tokens in the vault, then the substrate chain needs to know about this in order to mint a wrap token. And this needs to be reliable. This is the weakest link in the whole bridge because if someone finds a way to hack that system and to represent wrong information to the substrate chain, then tokens can just be minted out of thin air and you can steal money. And this is basically how a lot of the hacks work. For that reason, it's very crucial to us that the Stellar Oracle works 100% reliable. And this is actually the case. So an oracle quite often sounds like it requires trust and is centralized, but the Stellar Oracle, that's not the case. It's truly trustless, it's truly decentralized, and it's provably secure and provably as secure as the Stellar Consensus Protocol itself. That's a protocol for Stellar. How Stellar finds consensus, it's very special, and also our Stellar Oracle is tailor-made for this protocol. It really goes into the details of how this protocol works, and for that reason, it can be proven to be secure. Now finally, I want to show a roadmap of Spacewalk for Stellar. I already said that this is a Web3 grant project, and 2 of the milestones are completed, which is the Stellar Oracle and the basic structure, and we're currently working on the 3rd milestone, which is supposed to be finished by the end of the year, and this is to implement the collateralization technology. Now, I want to go to talk about Forex AMMs, the other important aspect for Pendulum. Let me first talk about the philosophy about how you build a blockchain and how you distinguish between the runtime and the application side. Let's first look at a general purpose blockchain like Ethereum. On a general purpose blockchain, you basically have 2 different layers. One is the runtime layer, which is the blockchain itself. This is usually hard-coded logic that rarely ever changes. And then you have the application layer. These are smart contract developers that build smart contracts on top of the blockchain. And of course, there's a lot of flexibility. You can constantly develop or deploy a new smart contract. And if you develop an AMM, then you usually do it as a smart contract. Now, on substrate-based chains or on parachains, you use a different philosophy, because they are not they are not general purpose anymore, but they are special purpose chains. And what that means is that this application layer is moved down a little. So the application layer now resides halfway in the runtime level and on the original smart contract level. So what that means is that out of the smart contracts that are important for your own use case, you try to abstract and find common components that all those smart contracts have in common. And you put them into a component you call a pallet on substrate. And this pallet is now part of the runtime. But something that's better than Ethereum is that on substrate and on Polkadot, it's very easy to change that. It's easy to integrate new runtime upgrades. So it's much more flexible than Ethereum. Then in addition to this, you still have your smart contract layers, where implementers can build different technologies. So if you have different AMMs on our blockchain, and they have common components, but they also have differences, and the differences will then be implemented as a smart contract. In order, well, maybe I can show it here again. So you have special pallets that abstract from common logic for those Forex AMMs, and you have different Forex AMMs as smart contracts built on top of this. Now, in order to understand why you need different, what those Pendulum-specific pallets actually do, let's have a quick look at how automatic market makers actually work, in case you're not familiar with this. I show a very simple example here of a so-called constant function market maker. A constant function market maker, you can imagine, has 2 liquidity pools in the simplest case. In this case, let's look at a market maker between US dollars and euros. And I represent those liquidity pools as jars. And what I also do is that I represent the amount of US dollars and euros in those liquidity pools by this diagram. On the x-axis, you have the amount of euros. On the y-axis, you have the amount of US dollars. And every single state of that automatic market maker is always represented by the amount of US dollars and euros in those liquidity pools. So you can always represent every state as a point in this diagram. In this case, I have 3 US dollars, 3 euros, and it would be represented by this red dot. Now, what a constant function market maker does in addition to this is that it introduces a price curve. This is the blue curve you see there. And a constant function market maker has the contract to ensure that the state, or this red dot, of the market maker always stays on this curve, whatever happens. Let's look at an example. Let's say I have some US dollars and I want to exchange them to euros using the market maker. What that actually means is I give some US dollars to the market maker and I take out some euros from that other liquidity pool. And let's say I want to have 2 euros. That means that the market maker now looks where the dot ends. If you move it 2 euros to the left, just goes up so that it lands on that curve again, and can then see that in this example it requires 3 US dollars from me for this exchange. So I need to give a few more US dollars than euros. It's not 1-to-1 in this example. You can also see that the price curve there is a little bit steeper. That actually represents that I need to give more US dollars. Now, of course, I can also go in the other direction. So if I start at the original point again and I want to actually make an exchange in the other way, then giving euros for US dollars then actually just means that the point moves in that direction. Let's just assume there is another person coming in who wants to make another transfer now that the state is at that point and wants to get even more US dollars out of this. Then that person would, for example, in this case, only get half US dollar for another 3 euro coins. You see that the curve gets flatter and flatter. And actually that slope of the curve really represents the current exchange rate. Now what's really nice about constant function market makers is that arbitrageurs will always come in to push that point around so that the point always lands at the point or at the position where the current slope or the current exchange rate really represents the external actual exchange rate of this currency pair. And that's really great for a user who wants to make an exchange with this market maker because the market maker will always provide the current actual exchange rate. That's great for the user, but it's actually not great for the liquidity provider because the liquidity provider carries a high risk due to these arbitrageurs. And you probably heard about impermanent loss. This is, for example, one of these risks that the liquidity providers have to carry. And for that reason, there are other concepts of market makers where the risk for the liquidity provider is lowered. One example would be a proactive market maker. This is a market maker that does not rely on arbitrageurs to represent the current exchange rate, but who actually uses a price feed oracle to use the current price of these asset pairs to determine what the actual exchange rate should be, and then constantly adapts their price curve. For example, it rotates the price curve around the current position so that the actual exchange rate is achieved. And that's a very great concept, definitely for the liquidity providers. Now, with all that knowledge, let's go back to the original diagram, and now we can understand what typical components are that Pendulum will provide. For example, there would be a palette for constant function market makers, or of course an Oracle palette, which is really important for many applications, particularly if you want to make DeFi on stablecoins. Then a token quality palette is also something that's important. And for example, there would be a proactive market maker palette for proactive market makers, and so on. And now you might wonder what those smart contracts still have to implement now that we have all these nice palettes. Now, I think it becomes clear after I showed that there are different kind of market makers that you can have, that there's of course still a lot of logic that needs to reside in those smart contracts. For example, you might implement different price curves, or you want to implement different structures of liquidity pools. The simple example that we saw was with only 2 liquidity pools, but you might have a market maker where you have liquidity pools for all kind of stablecoins, let's say 50 different stablecoins, and now you want to manage that with a single market maker. You also need to handle price feeds if you use an external oracle. There are also different risk models to avert risks for liquidity providers. And you also need to provide incentives for liquidity providers, otherwise they would of course not provide the liquidity. So let me finish with this final slide where I talk about the current status of market makers on Pendulum. There are 2 initial projects. One is an experimental project that we developed ourselves, and it's based on Uniswap v2, which is a very established market maker. We have 2 different implementations, one in Ink, the smart contract language for Polkadot, and the other one is a direct palette integration, and this allows us actually to balance the right feature set between the smart contract layer and the palette layer so that we can determine what the ideal API for our Forex ecosystem would be. On the other side, we have a next generation market maker, which is a community project on Pendulum, and this is called Project Amber. This is very advanced. It uses latest research. They published a white paper recently and describes some very interesting concepts in there that provides a market maker that has really low risk for liquidity providers and still gives a really high value for users who want to actually do an exchange with that. With that, I will close my talk. Thank you a lot. I want to invite you to get involved in our project, or at least to go to our link tree to check out what we have in there for you, or to follow us on Twitter, or to get involved directly in our open source project, of course, on Pendulum, on Spacewalk, or market makers, or to actually consider to build a community project on top of Pendulum. Thanks a lot, and if you want to connect with me, you have some links here.
Okay, thank you, Thorsten. Can you just take a mic for a second?
Yes.
So Thorsten actually attended to one of the side events yesterday to tour the beer. And I wanted to ask him if he tried some beer, if it was nice, and if you tried maybe some Czech traditional food, and what do you say?
The food is amazing here. I checked some Czech food yesterday. I forgot the name of this though. Some cheese, some pickled cheese, right?
Yeah.
Yeah, it was very nice.
Nakladaný sír.
I
Yes,
can't
he
pronounce
loved it. Oh my God! If you saw the face, he was like a baby. He just
Yeah,
got what
absolutely.
he wanted. Okay. Thank you, Thorsten, one more time. Thank you for your talk. Now we have actually 3 talks behind, 5 ahead, but before that we will have a half an hour break. You will have their amazing vegan soup, so just if you miss your lunch, now it's your time. And of course you can also visit the NFT exhibition, and yeah. So please come back and meet here at 1:30 so we can all hear the next talk, which is gonna be Vicky, co-founder from Polkadot. So yeah, see you in a half an hour. Ooh. Okay, so everyone is slowly coming, so I think we can start with the second part of the DOTBrno Conference. So welcome back. Hopefully you had some good food and you got more relaxed. And who went to see the NFT exhibition? Can I see hands? Okay, some of you have still time. But for now, please welcome our following speaker, the co-founder of Polkadot, which is NFT marketplace. Please, Vicky, come on stage. Applause for him, please.
Wow. So, yeah, hope you can hear me.
And Vicky is going to talk about the unified NFT developer experience. So welcome, Vicky, and stage is yours.
Hey, so hope you had really good food and lunch. And so thanks for being here. So my name is Vicky Wall, and today I'm going to speak about Polkadot, how to make experience on Polkadot better. And so who am I? I'm Vicky, co-founder of Polkadot, and I'm the technical wizard. So anytime you need to implement something bleeding edge in Polkadot, most of the time I'm doing that. And you can find me anywhere at WikiVal, so even GitHub or Twitter. And what's Polkadot? So it's open source NFT marketplace on Kusama and other parachains. So basically in whole Dotama ecosystem. And we are multi-chain powered. That means that we are already running on Kusama, Basilisk, Moonbeam, and Moonriver. And we are technology agnostic. So that means that we support Remark in version 1 and 2. We are supporting runtime palettes made by Basilisk team, and also we are indexing EVM smart contracts from Moonbeam and Moonriver, and also we are talking with the Ink team from Astar. And we are bounty based, so that means that anybody can join our team, solve some issue or some bug or add some feature to our marketplace and get paid. So learning by doing the best example. And we have already 300 plus forks, 200 plus stars, and 80 plus contributors around the globe. So pretty neat. And what's the architecture of Polkadot? You might think like, okay, just a front end. That's partly true, but our front end is running on Nuxt 3. It's a framework built on Vue, and we are using the latest composition API, so we are up to date with the latest tech. And we are building our own UI framework called Brick. It's written also in the Vue, but we are using the neo-brutalism style, so pretty neat and strong shapes. Also, we have other services which are written in Rust. We call them workers. They are running on the serverless or CDN or content delivery network, and we are using them for pinning IPFS metadata, IPFS images, so everything which has to run on the server side. And best, we have backend, or so-called backend. It's FireSquid indexers by Subsquid team, and on the top of that, we are running GraphQL API. So that means that anybody can basically query the data which are indexed by chain. And the best and last thing, we have our own packages, and they are written in TypeScript, and we use them for minting, for API, for Subsquid utilities, so we don't need to rewrite all the code again, and conditional rendering, which is part of reactive NFTs. And yeah, say hello to Minimark. It's our minimalistic implementation of Remark protocol. And the best thing or thesis of decentralized technologies is that you should not rely on single implementation, because something could happen. Also, in the Ethereum, you have Get, you have Parity, C++ version. So we try to implement our version of Remark, and it's covered by unit tests, so we are sure that it's according to the standard. And we are heavily oriented on the developer experience, so anytime you just create a new project, you just import the package you need, and it works out of the box. And the best thing is that Remark has two versions, version 1 and version 2. And as you can see, the difference of our implementation is basically changing from V2 at the end of the import to E2. And this code is literally the same. So no more magic. It just works out of the box. And Minimark has also batteries included, so anytime you need to, for example, create metadata or create NFTs or whatever else you need, it's out of the box in the package. And finally, we have API for Polkadot, so you can query and fetch all the NFTs across the DOTBrno paraverse. We have our API, and we call it UniQuery. And it's basically a query builder on top of the subscript. So instead of writing the GraphQL query, you just use our implementation. And we have two versions. One is the builder, and second is REST. And best thing, there is no server, so you are fetching the data directly from your client or from the user. So it doesn't need to process via the middleware. And we already support like 15 plus calls. So most of the stuff you would need is covered. And the best thing, directly in this presentation, you see the image of Code Dragons, and it's implemented via the Polkadot API or UniQuery. So this is the data right from the chain. So if somebody buys this NFT, the query string will change. So that's neat to have in presentation the NFT straight from the chain. And why is UniQuery so cool? As you can see, here is the GraphQL on the right. Before, you need to write something called GraphQL. Nobody knows what that is, or just few people. And on the right side, you see that using UniQuery is so simple. You just do one import, say that, okay, I want to NFTs from this collection, so some collection ID, and then basically you call it. So three lines of code, and you have complete NFT from the chain. And yeah, more to our vision, we try to be like cross-chain compatible, so we support Remark version 1, Remark version 2, Basilisk, Moonreal, Moonbeam, Bosom, and also EVM. And that's why we are looking forward for the XCM or XCMP protocol. And if you ever played with XCM, you know that, okay, it's kind of hard. You need to write like a lot of lines of code. So most of the people don't know what that means, because it's super verbose and super impractical to use in like regular apps. And luckily, we have Paraspell, and we bootstrap that. And it's SDK for cross-chain transfers. It's modular and easy to use, so any parachain can use it directly right now. And instead of like, writing hundreds of codes, you can simply wrap these calls into 2-3 lines. And it's super oriented for developers, so anybody can use it. And yeah, let's check the magic of Paraspell. So you see this code on the left. It's written directly in the same way in 3 lines of code. So parachain transfers made easy in 3 lines of code. And more to the, we would love to introduce more builders into the DOTBrno ecosystem. So Polkadot is an excellent example, like how to build on Substrate. But yeah, we want to iterate, like for other developers, we want to bring them to the ecosystem, and they want to iterate fast. So that's why we have Subscaffold. It's a template written in Nuxt 3 and Vue 3 with the native UI. And how can you imagine that? It's a front end with all the packages you need to bootstrap your decentralized application on top of the Substrate. And it's open source hackable, so anytime you can fork it and improve it. And Paraspell UI will be built on top of that. So you will see the real world example right into the code. And we also would love to support Ink. So anytime you would love to play with WebAssembly smart contracts, you can do that. And what's next for Polkadot? Our thesis is simple. We would like to be your single asset interface for NFTs on even our Polkadot or Kusama. And we'd love to abstract the technology from the user. So you don't need to care like if it's some remark strings, if it's like parachains, palettes, or whatever that means, or some EVM or WebAssembly smart contracts. Like we want to see your NFT, you want to interact with that and create new use cases on top of that. And all the necessary steps we would love to take away from the user. So you don't need to care if it's running on Kusama, if it's running on Basilisk, all the token swaps, token transfer, you don't need to care about that. That's super cool. And we would love to also simplify the token transfers across the parachain. So in 2 clicks, you can have the all XCM call right in your hands. And we are also brewing protocol for compatibility without various standards, all called PSPs. And yeah, we would love to also try the new things. And we already implemented the high-speed multi-chain search with Subsquid. So directly in Polkadot, you can search across the whole paraverse. So it's nice, sleek, and easy. And yeah, we are abstracting NFTs from the user experience. So you don't need to care like which chain test run. And we are looking forward for the generative art minting. So we are looking forward for DALI or Stable Diffusion or Midjourney. You already use that, and how to fine-tune that. And also we are thinking like how we can implement ZK snarks or zero-knowledge proofs into the marketplace, so you can share the secret NFTs or secret resources with the NFTs. And also we would love to check the on-chain art without need for off-chain code. So directly in the NFTs metadata, you can have more use cases. And also we would love to check like how NFTs are interconnected to each other. So we are using the graph NFTs to scale some models across that. And your contribution simply matters, and we are looking forward for more contributions. So if you are into music NFTs or GLSL or shaders in general, or you already have some on-chain use case, we would love to hear from you. Or even if you are building some on-chain game, we'd love to hear about you. So join our Discord. And to bootstrap your place, like bootstrap your project, we created something called Subwork, and it's your best Web3 retreat in the mountains. And we created the physical space in Slovenia to laser focus on your project or what you need. And it's based in Bled, Slovenia, so a couple of meters from the national park. And Bled basically is rated like a top 10 place in Europe. We are already up and running, and we already have like 20 plus visitors in the summer. And the best, we have opening ceremony finally in mid-December. So we would love to hear from you and see you in the Subwork. And don't forget to check the website, subwork.xyz, and Twitter, subworkblad. And thanks for having us today. And thank you for your contribution. You can see us on Discord /Polkadot. And don't forget to follow us on Twitter @Polkadot, and these are the team members. So thank you.
Does anyone have some question for Vicky? Okay, I have one question for you. So you mentioned Subwork. So what is the best plan or day you would recommend to do, like a idea for a trip, or if someone is gonna come there, so what they should do?
They should visit our Telegram group first. You can find the link in the Subwork website. And around Bled, there are many things to do actually. You can swim in the Lake Bled, or you can go for the hike in the Julian Alps. Really recommend, even if summer or winter. Or if you're really into bike, we can bike together. It's like really cool.
Okay, one more time, applause for Vicky. Thank you, Vicky. So now we are moving to another speaker, who is Todd Norton. So please come on stage. Do we have a Todd here? Ooh. Todd is missing. Maybe he is eating too much soup. Okay, let's give him some time. Did anyone see Todd here today? Does he exist? No one saw him? Probably someone forgot that has a talk. Okay, so we're gonna wait for Todd. How do you like it here so far? Who likes it here? Raise hand. Okay. Those who didn't raise a hand, he's coming now, today. Okay. So Todd is coming. Just in the meantime, he is the core cryptographer at Manta Network. Oh, here it is. So applause for Todd, please. Welcome him. He's gonna speak about snarks and ZK proofs and other things that NSA doesn't want you to know about. So here you go, the stage is yours.
How's this? Can you hear me now? Yeah? Sorry to keep you waiting. I lost track of time outside. Yeah, my name's Todd. I'm a cryptographer at Manta Network. We're a Polkadot parachain. And I'd like to talk a little bit about snarks, ZKP, and other things the NSA doesn't want you to know about. So I think we may not be in full screen mode. So ZKP and ZK snark, these are these letters that we see all over the place, right? Whenever we start talking about on-chain privacy, these letters start popping up. And I think that there's kind of a lack of good resources that explain what they are in a non-technical way. So that's basically the goal for today's talk, is to give a friendly introduction to what is a ZK snark. So I promise that I will not use any math. If you're a cryptographer and you work with these, I may bore you, but I'll try to entertain you at the same time. Time permitting, I will talk about what we use these for, okay? So what is a ZK snark? It's an acronym, and what the acronym stands for is zero knowledge, succinct, non-interactive, argument of knowledge. This is perhaps a confusing definition, so you may go online and look into literature to try to get some help. But what you find will be even more confusing. This is taken from the Manta spec, Manta white paper, or an old version of it perhaps. And so what I'd like to do today is say what it is, give the idea of what it is without going into this whole mess here. So I'll tell you a story. It's a story that takes place about 2 years ago, so winter of 2020. And winter of 2020 was a strange time. Most of us were probably confined to our homes. And some of us went a little bit crazy during this time. I know that I did. And one of the ways that manifested itself is that I found a Rubik's Cube somewhere in my apartment, and I started playing with it casually at first, and then a little bit less casually. Because just so a quick show of hands, who actually knows how to solve a Rubik's Cube? Anybody? Not a whole lot of people. It's hard. It's damn hard, actually, right? So I started spending a lot of time trying to solve the Rubik's Cube. And it got to be an obsession, a real obsession, and I couldn't do it. I could come awfully close, but I couldn't quite do it. And so I went online. I thought, well, all right, I'll accept help. What you find online is not what I was after. When you go online, you'll find algorithms for solving the Rubik's Cube, right? Steps that you memorize that will, yes, lead you to a solved Rubik's Cube, but it's not actually what I wanted. I wanted someone to kind of explain to me how does the Rubik's Cube work so that then I can solve it myself. So I needed a teacher, right? I needed a Rubik's Cube instructor. So that's what I searched for. I searched for Rubik's Cube instructor. It turns out that doesn't exist. Universities do not give degrees in the Rubik's Cube. Governments do not certify Rubik's Cube instructors, right? You're totally on your own when you need a Rubik's Cube instructor. I said, that's okay. I will find one myself. So I went to a tutoring website and I posted an ad. I said, hi, I'm a very motivated student of the Cube, and I would like an instructor who can teach me how to solve it. I'll pay $100 for a session where you teach me how to solve the Rubik's Cube. But of course I have to, before paying them, I have to verify that they can solve the Rubik's Cube. And as I said, there is no central authority like a university or a government that certifies people in their ability to solve the cube, so I have to do it myself. I have to come up with some way for someone to prove to me that they can do a thing, right? And this is what ZK snarks are about. So it's a good time to introduce a little bit of terminology around ZK snarks. They always start with a statement. And in this case, the statement is, I can solve the Rubik's Cube. Someone has to prove to me that they can solve the Rubik's Cube. So they want to prove the statement, I can solve the Rubik's Cube. And that person is called a prover. We refer to them as the prover, right? And in my example, it's this Rubik's Cube tutor. They produce some kind of proof that they give to a verifier, which in this case is me, because I'm the one who needs to verify that they can solve the cube. And then there will be some protocol that tells me what to do with their proof in order to determine if it convinces me or not, okay? And filling in each of these 4, perhaps 5 if you include the proof, blanks is what it means to define a zero-knowledge proof protocol, okay? So I will walk you through a zero-knowledge proof protocol for, finding Rubik's Cube tutors. So the worst version that you could use, this doesn't work, but it's a simple example, is you could ask them to send you a picture of themselves holding a solved cube. You're laughing because it's obviously a terrible proof, right? How do I know that they solved the cube? How do I know that it's not a brand new cube that's never been shuffled, right? So but okay, suppose that were the proof, then the protocol would be they send that proof to me, I look at that picture, and I've confirmed that the cube in the picture has been solved, right? So that's what I mean. I accept the proof if it's solved, I reject it if it's not. So there's a slightly, that's not convincing, right? So we need the proofs to be convincing. And one way that you could make that proof convincing would be, and this is what I did, I added to my ad online, I said, by the way, before I pay you, you're going to have to send me a video where you shuffle a cube and then solve it, right, in the video. Because I think that that's reasonably convincing, right? You could object, you could say, let's not go there, right? That's reasonably convincing. And I got this reply. Someone said, hello, I'm good at the cube, I would love to tutor you, but I'm sorry, I'm not willing to send you a video of me solving the cube. I said, well, why not? He says, well, if I send you a video of me solving the cube, how do I know you won't just study that video and learn how to solve the cube from the video, right? And then you don't need me anymore and I'll never get paid. And actually he has a very good point, right? The proof ought to be convincing to me, but it also ought to guard the secrets of the prover, which in this case are his secret Rubik's Cube solving techniques, right? And so if you send me a video of you solving the cube, it is actually true that you might leak some of your techniques to me in the video. And so we have a real problem, right? We have this situation where both parties want something kind of opposite. The verifier, I want the proof to be as convincing as possible, right? Which generally is going to mean that it should contain more information. Kind of intuitively, the more information it contains, the more I'll be convinced, right? The prover wants the opposite thing, right? They want the proof to contain as little information as possible because this is information that they are not willing to give away, at least not for free. And so it seems hopeless at first. And in that cold winter of 2020, I sat down and I thought for a while about what we could do about this, right? Just appreciate for a second how hard, right? How hard zero knowledge proofs are, right? Because you have to balance those two things. All right, here's what I came up with. Usually when we talk about solving the cube, it means taking a shuffled cube and moving its faces until one face is red and one face is green and one face is yellow, etc., right? And that's the traditional solution to the cube. But a true master of the Rubik's Cube would actually be able to do something much more impressive, right? They would be able to take a cube that is shuffled and put it into any other valid configuration of the cube, if they truly understand how it works. You see what I mean? Like, there are certain configurations that are valid for the cube, and if you really, really understand the cube, then you would be able to put it from one configuration into a different configuration. It's much harder. I admit, it's much harder, right? But I am going to pay you $100 to teach me, so it's not unreasonable to ask that you be good at it. So then what I did is I shuffled my cube and I took pictures of all 6 sides. And I sent those pictures to the potential tutor. And I said, okay, don't have to send me a video. What you have to send me is a picture of yourself holding a cube that is in this exact configuration that I just gave you. That might be 2 pictures, I guess, so that I can see all 6 faces of the cube. But anyways, that there is actually a satisfactory proof, right? It is convincing to me because if I shuffled my cube randomly, then I have it in one of the approximately billion configurations of the Rubik's Cube. And it is highly unlikely that someone who doesn't know how to solve the cube would ever achieve that configuration just by dumbly, shuffling it around. It's not going to happen. It's astronomically low. And from their point of view, it's also totally acceptable because sending me a picture of a cube in a given configuration, it tells me absolutely nothing about how you put it in that configuration, right? So we have a successful zero-knowledge proof protocol, right? So to be really clear about it, the protocol is this. I, the verifier, send you a picture of a shuffled cube. You, the prover, put your cube in that position and send me pictures of it. And then my protocol for verification is I look at your pictures and I compare them to my cube and I make sure that they match. Accept if they do, reject if they don't, right? And that's it. Like, if you follow that, then that's, a zero-knowledge proof protocol now, right? It's not a very useful one. It only actually works for this one statement, I can solve the Rubik's Cube, but it works really well for that statement. And it illustrates some of what we needed to explain about this definition, right? So I'll just go back through this quickly. Now that we kind of have an example in mind, I think we'll understand it better. So zero knowledge, this protocol is zero knowledge because their proof doesn't teach me how to solve the cube, right? So there's in a sense, zero knowledge contained in their proof. It's a picture of a cube in a position. There's not much knowledge to be extracted from that picture. Now, succinct is a thing I don't want to define precisely, but it roughly means that the proof is small and can be verified quickly. And let's just agree that 2 pictures of a cube is a small proof, and that me checking those pictures against my cube is a succinct verification. We'll just agree to that, okay? Non-interactive is actually not satisfied. So what non-interactive would mean is it would mean that messages go exclusively from prover to verifier. And in the protocol I described, I have to start off by sending them a message, right? So I cheated, and this is an interactive protocol. We could make it non-interactive. It's just, it really breaks up the flow of the story. And so, we could talk about it later if you care. But you can kind of, at least you get now what non-interactive means. You have a non-example of it. And then argument of knowledge, that's kind of clear. It's an argument that they know how to solve the cube. So this, obviously a made-up example. Why don't I talk about how we would actually use this on a blockchain? So on a blockchain, the prover is generally going to be a user of the service, of the network, and the verifier is usually going to be the chain itself. So what will happen is users will send proofs to the chain. They'll submit proofs to the chain, and the chain will act as verifier and check those proofs. So when the verifier is not a person but is a blockchain, then we have some constraints that we have to obey. We have to make our proofs succinct because the proof is going to go on-chain, and on-chain storage is expensive. The proof has to be quickly verified because on-chain computation is expensive, right? The proof is going to go on-chain, and that's a public ledger, and so the zero-knowledge property is essential, because if your proof contains some secrets that you wish to hide, then it's obviously not appropriate to put that on-chain where the whole world can see it. And the non-interactivity is, again, you know, the blockchain, you don't want to have to ask for messages from a chain. You want to post messages to a chain, right? So you, the proof, you ought to send messages to the chain. So you would like non-interactive protocols. And yeah, I mean, that right there, that's why those letters pop up all the time in blockchain privacy, right? ZK snark, it's just this acronym that defines a bunch of properties, and now I hope you kind of understand why we need those properties for a blockchain application. I'll wrap up by just maybe discussing what more realistic statements we might use on chain. You know, not filtering for Rubik's Cube tutors, but doing important things. So one kind of statement that comes up all the time is, I possess the keys to a wallet that contains one dot. That contains one dot. And right, that is a thing that you may wish to prove on chain. Maybe you're not actually spending that. Maybe you just need to demonstrate to someone that you have it, right? Well, you obviously can't post the secret key on chain to prove it to them. But if you can come up with a ZK snark for that statement, then you can convince them that it's true without revealing your secrets. Or if we replace 1 ETH with like an NFT, then you can prove that you're a member of a given community, right? I prove the statement, I have the keys to a wallet that contains an NFT from this collection. Now I've proven to you that I'm a member of some online community. If roll-ups are your thing, then you might want to prove the statement, I have verified a batch of 10,000 transactions. And instead of actually verifying those on chain, maybe you can just submit a proof that you did it on chain, and the chain can verify that proof, right? And we start getting ZK rollups. I think that I've used up my time, so I'm not going to go through Manta's private payment protocol, but it is a really cool example of how these get used, and I'm here today and this weekend, so if you want to talk about it, I'm happy to explain it. But yeah, I hope that you got something out of that, and thanks for your attention.
Thank you, Todd. That was great. So does anyone have some? Okay, we have one question.
Hey, Todd. Thanks a lot for the presentation. It was really amazing, very intuitive, and very entertaining. Thanks. And also thanks a lot what Manta Network is giving to the whole Polkadot ecosystem with your privacy technology. I think it's really great what you're doing. Also very much believe in privacy. I think it's a basic right for the people, but I think also for the adoption of blockchain technology for businesses, for example, privacy is really important. They don't want to expose what kind of transactions they do. Competition should not know all those secrets. But I think there's an elephant in the room, namely what happens to Tornado Cash this summer. This is really a shame because now there are a lot of naysayers that say that this kind of technology at the end is only used for money laundering. It's a real shame. I'm frustrated by this. Also, a developer had to go to jail for whatever reason. Maybe there was really some shady thing going on. But what do you think about that? And what do you think how the blockchain world can solve this kind of misunderstanding about privacy technology?
Well, thanks for those kind words, and yeah, it's a great question. I think one thing that has to be said is code is speech, right? Code is speech, and that doesn't escape the fact that, you know, there is a great deal of power that does not want people to transact privately, and part of that is because there are actual bad guys who want to transact privately. But there's also, like you said, privacy is a human right, and there's a whole host of good guys who want to transact privately, and like neutral guys, you know, neither good nor bad, who want to do it. I think that one thing that, and this is in the MantaPay protocol and not a part of the Tornado Cash protocol, is that you can actually incorporate optional compliance into such a protocol. So we have a system, and it's not unique to us, but we have a system of viewing keys. So there's sort of a hierarchy of the spending key, that I must keep secret, and the public key that I can publish to anyone who wants to send me money. In between these is a verifying key that would allow somebody to decrypt my on-chain transactions, but not to spend the money that's in my wallet. And so if you need to comply as a business, for example, right? Businesses are a great example of this. They need to comply to certain entities. Well, they can share a verifying, yes. They can share a viewing key with those entities, and that would unshield the transactions that they've made on chain, right? Without giving that entity the ability to spend their assets, right? So this is, I mean, one approach to that question is to try to find a middle ground, right? Where privacy is default and you have the option to sacrifice some privacy for compliance purposes. Yeah, I hope that answers your question.
Okay, anyone else? Okay, Todd, thank you for your great talk, but honestly, I missed one thing. Do you know what I missed? There was one thing missing.
What was that?
And it's real Rubik cubes. So we could actually try if we can solve that, right? How we can answer if we can try.
Okay, I'm going to talk to Manta about getting some Manta branded cubes that I can pass out at this talk.
I think you need that.
Yeah. Hey, thanks for the invitation.
Applause for Todd. Thank you, Todd. So, very soon we will move to our next break, but before that we will have one more speaker, who is Matyáš Sobocsan. So please come on stage and applause for him. He is the CTO of Apelon, and I would like to just mention that Apelon was one of the organizing teams, so thank you for that, Todd. And he's going to be speaking about tooling on Polkadot. So, stage is yours.
Ahoy, Brno. How are you doing? All right, thank you very much for coming here and giving us this chance to speak here today. Before I open up my presentation, just a quick question into the crowd. How many blockchain developers or Web3 developers do you think there are today building Web3? Rough estimation. Close. So we have roughly 17,000 developers building Web3 across all the environment. Compare that to, for example, JavaScript developers. We have 17 million developers building on JavaScript today. So you can see there's a long road ahead of us on how to start the mass adoption of Web3, blockchain building, and really bring it to the masses, bring it to the end users to create tangible or real-world applications built on Web3. So the issue today for a new developer who's coming into the space and wants to start building on Web3 is, first of all, they don't know where to start. You have so many blockchains going around from, let's say, Polkadot in this case is layer 0 with all the parachains on top. You have Ether, Solana, Tezos, Avalanche, I mean, you name it. So you have to start somewhere. You have to pick a chain to start building on top of it. But once you choose one of those chains, you run into the second issue. What am I doing here? How do I start? Where do I start? How does the code even work? Where are the snippets? Where are some templates? Who to talk to? How to work with anybody in the ecosystem? Because it's such a huge ecosystem that it's really difficult for those developers to step into it and start building on top of it. And building on Web3 isn't easy, but it should be. So there are like 6 areas where we see that there should be improvements made in order to make applications more, let's say, more accessible to the user. So one would be really cross-chain composability. So really work between chains without any bridges, but the real back-end infrastructure like Polkadot uses with the cross-chain messaging protocol, where parachains can communicate with each other on a real protocol level. Scalability by design, to really, when you reach a certain milestone, reach a certain, let's say, scalability or a certain size of your application, that you can continue growing on this chain without running into issues. That's how we, for example, when we initially started building, we started on Ethereum, as we were building an enterprise-ready application. And at the end of the day, we said, look, I cannot be responsible for a new NFT mint going on, which is clogging the network. The gas prices go through the roof. And I have to tell my enterprise customer, look, I'm unable to protect your data because new CryptoKitties are being minted. Okay? Easy access to multiple parachains. I mean, today we have, I think, 27, 28-ish Polkadot parachains live on the network. And each of those parachains, they have their own stack, they have their own token, their own code snippets, their own setups. And you have to learn each parachain on their own to understand and start building an application on top of it. All those parachains, as mentioned, they all have their own token. So unified pricing. If you want to build an application, you can't be your own custodian as well. You can't be your financial expert to also keep all the wallets, maintain your balances to be sure that you can pay all those transactions at the back end. Upgradability and agility, and also transparent governance. I'll sum it up a little bit. So basically to have a unique set of rules on how you're going to maintain your app in the future. And you could guess that obviously that's why we're here today. So Apelon is kind of the one-stop shop or the one-stop building platform to enable developers to build on Web3 easily. So how do we do that? So, and why use Apelon? As mentioned, do I have a slide? Yeah. So each of those parachains on their own, they're kind of an isolated case. When we talk to different parachains, like for example, Kilt, Crust, Fala, Moonbeam, they are all experts in their own field. They have the domain knowledge. For example, I'll take Kilt as an example because we're going to go a little bit deeper in the next slide. But Kilt, they're identity solution providers. They provide digital identities, and their domain knowledge is around identity, right? And they focus on identity only. If you want to build a next generation app, you cannot just rely on identity. You need some storage to put the data somewhere. You need some processing power to host your applications. So this is where other parachains need to come in, start communicating to build your front-end applications. The problem is, like I said, they're very specific in their verticals, right? They have the expertise, they build the solutions, but once it comes to the business logic and going beyond that, you need something to catalyze, or let's say to consolidate them together to build a real application. The same goes then from the custom token, volatile token, and challenging user experience and documentations. Before you even can start building, you have to go through a large library of examples. And this is basically where we come in. So we take all this knowledge and all the expertise that the different parachains are building, and in this case, our MVP is being built on top of Kilt and Crust, and simplify it into simple APIs to enable Web2 developers to have an easy on-ramp onto Web3 without having to learn the languages like Substrate, Solidity, Rust, and so on. They can stick with their own languages that they're familiar with, like Python, Java, TypeScript, C, whatsoever, and just call our APIs. So our solution will consist, or is built on top that we have the parachains let's say, Polkadot as the foundation protocol, with purpose-built parachains on top, which each serve their own purpose, like I said, identity, storage, computing power, hosting, and so on. And we kind of merge them together into simple APIs where you as an end, or the developer on Web2 and building into Web3, just call our simple APIs, in this case, for example, create user with email and password. You will get a digital identity, Crust, storage, get storage, 5 terabytes. We do all the magic at the back end. So the 5 pillars that we're going to build at the beginning is Web3 authentication with Kilt, Web3 storage with Crust, Web3 hosting with Astar, Wasm, and Fala combination. And then the third one, let's say the last one is basically Web3 up to you. We're going to build the platform in a way that is highly governed by its developers. We're not just going to out there and say, we think this is the best. This is why we also have our own token, the so-called Nectar token, which will be used to govern the platform itself. So you will be the ones deciding which features are going to be implemented in the future, how we're going to expand the ecosystem, which parachains get introduced into the system, and so on. And to just give you an example on a real-world use case that we the most of us know. So a simple Instagram clone, how could it look like on a Web3 ecosystem? So in this case, current Instagram, the data ownership is questionable. Obviously, Meta, Cambridge Analytica, and so on, you know. The user profiles are served centrally. Basically, everything is controlled by Meta in this case on their own. The user has no control, no copyrights whatsoever. With a Web3 clone, you could store your data on IPFS with Crust. You would create a digital identity on Kilt, and you would be the owner of your content that is being uploaded to this Instagram clone. As mentioned before, so the token of the Nectar token will be highly integrated into the governance of the platform itself. So we will do the research for you, propose some amendments to the platform, to the community, whereas you as token holders will be able to kind of influence the development of the platform itself. But we'll also open up like a Polka assembly-like, let's say, environment where you'll be able to kind of push new ideas, new features into the platform, and then together with the community, we're gonna then develop those into the backend. I'm gonna give you a quick sneak peek how the platform actually looks like today. So once you go into the Apollon website, we have the possibility to either sign it with a Web3 compatible wallet like MetaMask or the Sporon wallet from Kilt, or you can just go the old way with email password. Once this is done, you would give your project a name, give it a short description, start your project. Once you start building, you get introduced to the platform where you select which kind of services you want to use. And the idea was basically to kind of create a managed service infrastructure like AWS is today. You don't care if AWS is paying their electricity bill. Do they have enough climate in the data center? Do they maintain the service? Do they do the updates? You want to use the service. You want to have a specific amount of CPUs to run your application. You want to have a specific amount of storage, and that's it. Then you start building. And this is the same case for the Polkadot ecosystem, what we're building here. So you select the services that you want to use. After that, you get your APIs, and then you can start building in a familiar way that you are used to, like I said, in your familiar language. I hope I gave you a little bit info on how this is being structured, what we're building here. Please join us in our Discord channel. It's still being built up because the initial community was built on Telegram, and I'm now doing more or less like a very developer-focused Telegram or Discord channel on Discord. The MVP will be ready by the end of the year, and we invite basically every one of you to join our closed beta if you want to try it out, play a little bit around, and see how much we could influence, how we can catalyze, let's say, the adoption of Web3 with the help with the APIs that we're building. Now, before I finish, or let's say the main part is finished, I would also like to thank Polkadot for our partnership in the past few months. As you've seen in the presentation of Polkadot, the guys moved to Bled in Slovenia, which is a very, let's say, famous place in Ljubljana, in Slovenia for the nature, but they're also very known for their desserts. The cream cake is one of the famous desserts that comes from Bled. And as a, let's say, token of our appreciation to the Coda guys, or let's say more or less a non-fungible token of appreciation, I have a unique NFT that's been done by an artist in Slovenia. It's a one-of-a-kind NFT minted on OpenSea for now, unfortunately, but we hope to bring the whole collection to Polkadot. So yeah, I would like to give it to the Polkadot guys as a token of appreciation. Thank you for organizing it, and thanks for being here. It's heavy. It's a stone that are used for roads and so on. Yeah.
I mean, it's so nice. I have no words. I mean, thank you for this stone. I mean, we always wish for this, you know, to have our own stone as an NFT. Thank you for your talk. Does anyone have some questions, or are you good? Okay. Thank you, Matej, for your talk.
Thanks for having
you to
us.
be here. Please, one more time for applause. Okay, so since we want to give you a chance to stretch your legs, maybe breathe a little bit, yeah, but now I have to take it home. Thank you. So we will have a 1 hour break. I think it's even longer because probably our speakers doesn't really want to talk to you because they are super quick. But we will meet here at 4:10. And just to inform you, I will be switching the moderating position with one of the guy from Apollon. So just so you know, you're not in a shock, I'm not here anymore. So yeah, enjoy your break. Definitely go to check the NFT exhibition. go check the exhibition upstairs and yeah, have some nice food. Thank you.
Start in approximately 5 minutes, just for information. One, two, one, two. Okay, so hello everyone. Welcome back to the presentations. My name is Patrick. I'm a growth manager at Apilon, but I'm also one of the co-organizers of this event. We're trying to do it in the true decentralized manner. So one of the organizers, as you see, is Apilon, the Polkadotters, and the Kodadot. That's why now I'm here instead of Clary, just to do it, as I said, in a true decentralized manner. So the agenda for today is we have one talk by Tina Rush
from Kilt Protocol. After this presentation, there will be the Alice and Bob, or Tommy. This is the gentleman right here. After these two presentations, it's another short break, and then the final thing, the panel discussion. And after the panel discussion, you can guess what comes. Well, it's the after party. I hope you all claimed tickets. In case if you didn't yet, you can find the link in the Telegram group or on the Twitter profile. So now I'm gonna give the microphone to Tino, who's gonna tell us more about the digital identities and give us a brief overview on what Kilt Protocol does. So, Tino?
Yes, hello. So I'm Tino from Kilt Protocol, and we heard a lot about today what you can do with blockchain, especially the things everybody talks about, DeFi, NFTs, but there's a lot more that you can do with the help of blockchain. And one of those things is basically regaining control of your data. Because I think you all know, we just gave up on it by making accounts at Google, at Facebook, our Apple accounts, whatever. So our data is not in our hands anymore. And Kilt Protocol is there to actually solve that issue. And that's what I'm going to talk about. So now it's, no, I'm pressing down. It's, I can do so. It's working. It's okay. It's okay. I think it was a focus. I have focus on my speaker notes, and now the focus is there. Then now it's working. Okay. Yeah. So I have to go a bit into history to give you a little bit of context. So everything started with the invention of the internet, and we had those initial protocols. So there's the IP protocol, TCP, UDP, SMTP, you name it. And those protocols itself are a great foundation for the internet, but they don't add that much value, basically. They are important, but for users, if you just have the SMTP protocol, I doubt, I mean, okay, we are here in Web3, perhaps 1 or 2 people could send an email by hand, but I think the West couldn't. The West would just rely on applications which are built on top of that, what we call Web 2. So if you go to Gmail, that's a prime Web 2 application. So it builds on top of IP, TCP, SMTP, and HTTP to serve you a unified experience. You open a browser, you go to Gmail, and you write your email. And you don't have to care about IP, TCP, SMTP anymore, nothing. So there is a lot of stuff that got built in the Web 2 era, so search, we talk about Google, there's also storage and transportation, so there's a lot of value which is there, which is given to us by Web 2 companies. And that's not a bad thing, but yeah, it developed into the wrong direction. So there's a lot of value in there, but now we are basically one step further. We are, come on, that was the wrong button. Now we have Web 3, and the big distinction is we still have the base protocols, so the thin layer at the bottom, but then we have like a fat protocol layer, which is implemented by all our blockchains and our power chains, which provide a value to the user, but not in a really usable way. So if we think about Quast, for example, which provides a framework for storage, or in general ownership, which is like the basis of all NFTs and ERC20 and whatever. And we also have like protocols for identity. This is where we came from. So Kilt protocol is about identity. And those protocols basically provide value by building a foundation where new D-apps could be built on top of that. And on top of those fat protocols, there are then the real applications, so D-apps, basically. As an example, so there is, for example, from us, there is DID sign, where you can use your keys to sign files and send them around, and then the other person can be sure that the file comes from you. Or social KYC, where you can get credentials, or Piñata is also a service built on top of storage protocols. DEXs and all the DeFi applications, they are all user-facing applications which are built on top of the Fed protocols provided by our blockchains. So this is basically the setup where we live in. And Web3 adds real value. Can I scroll up here? No, I can't. I will go back to like the analog version. That's always working. Basically, if you look at that, so we had that Web 2 in the beginning, and it solved some problems. So it gave us nice UIs, it gave us value because it helped us in our daily lives. Because if you want to send an email, you don't write the SMTP messages by yourself and encrypt it by hand. No, you are just using Gmail. So, but the problem with that is all those functionalities are basically provided by big centralized companies. And to actually use them, you have to give your data to them. That's their business model. You give them your data and they give you a service for free. But as we all know, it's not for free, we're trading our data. But Web3 can actually really solve that and help with that because so common good functionalities, for example, identity, payment, and ownership are implemented in a distributed way so that there is no central authority which basically has power over that. And with the help of that, we can have the control of our data back in our hands because we hold the keys. We are the ones who have the keys to our wallets, which then prove our ownership of our tokens. We have the keys which encrypt our data on our own devices. So the ownership of the data comes back to us. And that's like a fundamental shift from Web 2 to Web 3. Yeah. And also, when you are basically in the Google ecosystem, for example, not everybody can build an app on top of Google. I mean, yes, they have some SDKs and it's possible to integrate with it a bit, but you don't have the freedom to actually build on top of that. But with Web3, we have those fundamental free protocols, which can be used by any builder. Anybody here can just leverage that and build creative apps on top of it. And that's also a big difference. Yeah, and if you look at that, I think so the time will not go backwards. So Web3 is here to stay because, yes, we only have like 70K developers currently in Web3, but those people who had a look at Web3, they see the benefits of it. They see that they don't have to give their data to some central organization which then sells it. And that's why it's unavoidable. It's there and it's there to stay. Yeah, so what is identity? That talks about identity, and identity is who I am. So this is me, but identity is not only me, it's me, especially when others confirm it. So there are credentials. So here, for example, there's my ID card, there is my driver's license, for my health insurance, the card, Lufthansa Senator card, and also I have a degree from a university that's also certified, and those are all like trusted entities which certify who I am, what I can do, and all those things. And yeah, but how does it currently in the real world works? So what is an identity transaction? An identity transaction is always when I want to prove my identity to somebody to have a benefit from it. So if you want to go to a concert also, you have to prove that you own a ticket. Or if you want to go, for example, to a liquor store and want to buy a bottle of alcohol, of nice scotch, then you have to prove that you're over 18. So how do I do that? I go to that store and then I show them, here, I have my ID cards with me, and I show them to them. Then the shop owner looks into my face and sees, oh, that's the very same person. So that subject equals the credential. And then all they have to do is they have to check if they trust the credential. So in the top line, there is written Bundesrepublik Deutschland, which says the state gave that to me. And there's my date of birth, which basically says I'm over 18. So and then they checked, and then they say, okay, this is Tino, he's over 18, he's allowed to drink whiskey. And then I can get my bottle of whiskey. That's like the normal thing in the world. But what are the benefits of that process? I mean, it sounds like stupid, I know, but it is like a super old concept, and it has a lot of benefits because it is not centralized. I will show you why. So basically, there is an asymmetric trust. So I trust my government that they give me like a credential, and the shop owner also trusts the government that they don't like issue passports to random people with random birth dates. So it is really scalable because the verifier, so the shop owner, he doesn't have to ask my state to verify that, that passport. They only have to look at the passport. So it's not like an OAuth where you first send a request to Facebook, which then creates a credential and sends that back to the person who wants to check what's your email, what's your identity. No, it's not like that. We get that credential once, and then we can show it, and there is no way that my government can say, Tino's a drinker. He went to the store and buys whiskey all day, because there is just nobody who, it's just not possible. It's not in the concept. And yeah, so the issuer is really not part of that identity transaction. The issuer just creates a credential in the beginning, gives it to me, and then they are out. And then I can just use that credential. And this is good for privacy, because I mean, I could also use my passport and prove that I'm over 18 to go to other locations, which I perhaps don't want to share. And yeah, so, but my state will never know. That's actually a cool concept. So with Google or Facebook, that wouldn't be possible. They would just record, yeah, he has like, he bought like 5 bottles of whiskey last week, so we will give him some ads to buy more expensive whiskey. That's what would happen. Yeah, okay, so in short, what's Kill Protocol? We are basically, do I have it here? Yes, I have it. We are basically a decentralized blockchain system, which is also permissionless, so everybody can just use it, which brings that concept of having an identifier and credentials which are attached to that identifier to the blockchain space. And that's basically our core thing. So you can manage identities and credentials, and those identities can not only be used by humans, but you can also issue have identities for like cars, for example, or services, machines, assets, for example. A DAD could have an identity, not a DAD, an NFT could have an identity. So yeah, anything that needs identity can have identity and credentials for that. So yeah, but what is then, okay, now we know what's identity. Identity is who I am and the credentials around, but what's actually digital identity? And digital identity is just really an identifier. It doesn't have to be my face. It can just be an identifier plus credentials. This is what it's all about. And what do we take as an identifier? That we take DIDs. So DIDs are just decentralized identifiers. So everybody can issue that identifier to itself. So it is something that comes from you. It's not assigned to you by the state, but you create your identity. You create your DID by generating a secret passphrase, your 12 words, save it somewhere, and derive your identifier from it. And yeah, so the nice thing about that is that the DID is also then, there is cryptographic material attached to that DID, like a public key. And because of that, you can, because only you own that private key, which corresponds to that, you can prove that this is your digital identifier. Yeah, and then we only have like those verifiable credentials. I will call them VC in short. In the next few slides, I will tell that 1 or 2 times. And they are just issued by trusted entities. So like, I mean, the state could issue me my passport, but there could also be like a service which issues me like a credential which says, you are the owner of that email, or you are the owner of that Twitter account. And then you have this as a credential and can then prove it to anybody who wants to know that you are not a bot, that you have an email, a Twitter account, and a Discord also. You can just prove it without going to Discord, Twitter, Google to get that information. You get that once, have it as a credential, and then you can just use it wherever you want. So what are DIDs? To just give you like the key information about that. So a DID is just an identifier, and if you look at that here, oh, I can't point it. This is a DID. It looks like a long string, but it's basically just DID, killed, and this is just a base 58 address. That's what it is. It is unique, so it's just, I mean, you know, it's a public key actually, and if you generate it randomly, it's very unlikely that another person will have that very same identifier. It's not impossible, but it's very unlikely. And yeah, a DID is verifiable, so there are different keys attached to it in the end, so you have for different purposes, different keys there, and you can also rotate those keys, so you can add new keys when the old ones get leaked or whatever. And so it is verifiable. You can prove your identity to anybody. And it is decentralized. So that identity management, it doesn't even depend on KILT. So DIDs are even bigger. So there is like a whole ecosystem of people out there who care for a decentralized identity. And that DID spec is even an official spec by the W3C now. So yeah, so the W3C, for example, says, what is a DID? A new type of identifier that enables verifiable decentralized digital identity. And this is really from the 1.0 spec. And now, just a little info. What do you think? Who was totally against this spec? Who was against that this spec was written and was released as version 1.0? It was Google, it was Mozilla, it was Apple. They were fighting that because they fear it, because they feel like we are breaking up their monopoly. We are taking the user data back from them and put them back where it belongs, to the users. And that's a threat to them because it's threatening their business model. And that's why they put much effort into that to actually not let DIDs get standardized. So I think that's a good sign, right? Okay, yeah, and what do we do in KILT? Basically, we have that DID, you can register it on the chain, and then you can get credentials issued to it. And how does it work, actually? So, so we have that blockchain, you can put your DID on it, you can go to attesters, so those trusted entities, so like the state or some trusted entity who gives you credentials, and those credentials are then not just written on chain, so everybody can look them up. No, they are hashed, and only the hash of the credentials is stored on chain. Why do we do that? Because I don't want to share all my credentials with everybody on a public blockchain. That would be like if I would have a blockchain account and I would just write my banking account, my ID card number, and everything on there, publicly readable. That wouldn't be nice. So we just put the hash there so that everybody where we show our credential can also hash it down. So he sees then the information, hashes it down, and then he can check if that hash is written on the chain and who wrote it on the chain. So which attester did it. And this is how it actually works. So why is it written on chain at all? I mean, we could also just create a signature from the attester, attach the signature, and give it out to somebody. Then they could just verify the signature and know, oh, it's from that attester. The problem is, with that way, we couldn't revoke the credentials. Sometimes it's important that you give out a credential, that you give out a credential, and at a later point, you want to revoke it because the person left the company, or I don't know, you just don't want that credential to be valid anymore, and then you can just revoke it. Then you write to the hash on the chain, oh, by the way, this credential is revoked. And then every verifier, which looks at the credential, looks it up on the chain, sees, oh, there's the hash of that credential, so it was written there. But then as the next step, they look and see, oh, it is revoked. So I shouldn't accept that credential and shouldn't sell Tino that bottle of whiskey. And yeah, that's basically the whole idea besides that. So we have that beautiful standard. We have DIDs and a way to store verifiable credentials. And now what we need is we need applications on top of that. And for this we have like a charter which is called BTE, and they basically build D-apps on top of our chain. So we have a few examples. So there's, for example, DID Sign, which is a signing service like DocuSign, but decentralized. There's Social KYC, where you can go and can say, here, I have a Twitter account, I have an email, I have whatever, and then they check that and give you a credential over that. And yeah, so basically, so BTE uses just our SDK to build all those applications. And yeah, why are they good? I mean, they are more cost efficient than the existing Web2 solutions. Just think about DocuSign. DocuSign costs a lot of money, and all what they do is like creating signatures and storing them. So it's like no-brainer for crypto people. And so that's why we can offer that service for free. And also, in DocuSign, the company behind DocuSign knows about everything. You know, because you have to send the documents there, they manage it, they create it, they log it. I guess they analyze it. I don't know, I don't want to blame anybody, but they could. And yeah, so that's why our Web3 applications have more privacy inherently than the Web2 counterparts. Yeah, and that's why they are also more secure, because if you don't have like a central place that you can hack to actually get the user data from hundreds or thousands of users, that's like a super nice honeypot for hackers, right? If you know, oh, there is one server which holds like 100,000 records of user data, that's a good target. I would really like spend a lot of energy in hacking this just to get that data and sell it for money. But if we have those information not stored on a central service, but at the user, every user just holds like one set of data records about himself. And that's not an attractive target, you know? You have to spend time and money and energy to hack that one person, and what do you get? You get one row of data. And no one does that, because it's like, I mean, yeah, if that row of data is super valuable, then perhaps, but it's much more likely that a service is attacked where there is much more at stake than like one single line of user data. Yeah. So in the end, I hope we will just replace every single Web2 application because of those benefits. Yeah, so just as a picture to bring it into your mind one more time, this is how it currently works. We have like that one platform provider, and the user goes there, and their credentials, so their rows of user data, is stored within the platform of the cloud services. And whenever there's like a verifier or a service, an OAuth client basically, they get that information from the platform. That has major drawbacks, because the service and the verifier asks directly at the platform. So the issuer of the data is also involved in the identity transaction. So the platform knows that I want to buy whiskey. They want to know in which club I want to go. They just know it, and they will give me ads after that. And so the keys are also just held by the platform provider. And this is really like the main concept how OAuth works. So there's one central place where all your data is, and that data can then be given out in chunks to verifiers, but it always comes from the central platform. But yeah, this is how it's working now. So here we have the user in the center, not the big platform. Actually, there is no big platform anymore. The big platform is the chain, which is above everything, or below here, but get what I mean. So the user here, he has the keys. He holds all its credentials, and he gets those credentials by getting them from trusted entities, from the attesters. So Social KYC, the state, whoever, and they give the credentials to the user, and the user holds them. They write, as I said, the hash of the credential to the chain. The user can also verify that its credentials are written to chain by looking at the chain. And then when it comes to an identity transaction, the user decides which of its data he takes, or which they take, and show it to the verifier. The verifier can then inspect that data, look it up on the chain, if it was really issued, and who issues it, and if it is revoked or not, and can then do it. So I think that that model is like 100 times better than that centralized model. Yeah, and it re-empowers the user, because as you see, the user is in the center. The user holds the keys. The user holds all the data. And that's like how it should be. To make it in a little bit more confusing graphic, so here, just really one more time. So how does it work, that whole flow? So here we start with the claimer. The claimer is the user. So the claimer says some claim C. Claim C is, I am the owner of a specific email address. And he gives that to an attester. The tester now looks at that claim. Okay, then he needs to verify, does that user really have that email? He will do so by sending an email which contains a secret code, which the user then has to provide back to prove that he owns that email. You all know that. And then the tester writes the hash of the credential. He writes the hash of the credential to the chain and gives the attestation over the credential, so the verifiable credential basically, back to the claimer. The claimer stores it then locally in its browser extension or, I don't know, on his hard drive, and now has a credential. So now, the user can use that credential, share it to verifiers. The verifiers need to do a cryptographic challenge to the claimer to prove that the claimer actually owns the DID, which is written in the verifiable credential. So credentials are always issued to DIDs. So then he knows, okay, I see the credential, I know that the subject in the credential is that user, because only that user can solve that cryptographic challenge. And then the verifier can check the hash of the verifiable credential on the chain, looking if it is revoked or not, and he can decide that he trusts the attester who attested that specific credential. And that's really like the whole flow. That's what it's all about. Yeah, so in the end, basically, DIDs and verifiable credentials make it possible that we have a digital identity which is under our control, which is not our Facebook profile. I think nobody has a Facebook profile anymore, or I don't know, but I think not in this room here. And I will show you through one more example with a new feature, which is currently being rolled out to our testnet and will hit our mainnet very soon. And this is asset DIDs. So as I said in the beginning, not only humans can hold DIDs, but also assets. And yeah, so let's look at that. So for example, in Ethereum, you have the ENS concept. So you can say, okay, you have an Ethereum address, and you can link one ENS to this. So this is already starting to build a bit of an identity. You have like an identifier, and you attach at least a name to it. That's okay. You don't have to remember all those 160-bit addresses from Ethereum, and you can just use that name. That's already a good starting point. But what can we do with DIDs? So with DIDs, so here we have our DID, it starts with that, and we can link different addresses from different blockchains to it. We can link Ethereum addresses, we can link Kilt addresses, we can link Moonbeam addresses, Polkadot addresses. This is not a Polkadot address, but get what I mean. So you can link any number of accounts to your DID, and we also have a feature, it's called Web3 name. So you can also link a name to your DID, the same way as you can link an ENS to an Ethereum address. So this is already more powerful. But now, we can even put stuff on top. So, as you might already thought, you can also attach credentials to the DID, which makes it super powerful. And on top of that, you can also define service endpoints for a DID. That's basically, you write publicly into the information of your DID some URLs that you choose. So those URLs could point to credentials. They could also point to your MySpace account, whatever. So you can link a lot of more information to the DAD than just the name. So now, the asset DADs, as I promised. Nearly falling off here. Okay, so asset DADs. So we start with me, Tino, even with glasses. That's nice. I have a name, Web3 name, and I have some credentials and a DAD. So this is a person. But now we can also have an asset DAD. So let's say we have an NFT on any chain from any type. It comes from some contract and it has an ID. So because NFTs normally have like IDs. So the asset DAD consists of those types. We just say an asset DAD is an identifier which says on this chain, this contract, this NFT. This is, so all those information just concatenated together in the right format form the asset DAD. So now we have an identifier for an on-chain asset. And now we can do the very same thing that we did with all the other DIDs. We can add credentials to it. So I, as a person, could issue a credential to that asset. So I could, for example, say, I created that asset. And then I just create that identifier, I create that credential, and since an NFT cannot hold any credentials, because an NFT can't hold credentials, because they don't have a key, they don't have a private key, it just doesn't work. Those credentials have to be public. So you can store that information that I created that NFT publicly on the kill chain as a credential, which is then also verifiable. And yeah, that's like the basic use case for asset DIDs. So to make it a bit more plastic, here I am a user and I create an NFT. And I create it on an NFT marketplace. And so I created that NFT, and now I just claim creatorship at that NFT marketplace. That NFT marketplace knows that I'm the one who created that, because I was the one who was logged in and clicked on the button to mint that NFT. And then they issue a credential for that asset, which says, Tino is the one who created that NFT. And now everybody, even after the NFT is sold, whatever, can verify who was the original creator of that, without going through a history, and it don't only have to contain the creatorship, but also perhaps what was the company that I worked at the time when I created that. So to, for example, say, this is an NFT which came from the Polkadot team. You could just issue that once, then the NFTs could live on. Perhaps even the company stops existing, whatever, the credential would stay there, and everybody in the future could always say, yeah, this is the initial creator, and the initial creator is also linked to this company, and so this is an authentic NFT and not like some scam. And it even works with like physical products. So let's say we have a manufacturer which manufactures really, really expensive clocks. So they produce that, a physical good. And as you have seen perhaps with wine, or I think also like watches, those manufacturers start to create NFTs which are coupled to the physical good, so that you can, in an online world, basically show around here, I have that Rolex, I have that. You know, it's always the same. It's like showing it off. And so there's an NFT. And what they also can do is they can issue an attestation which says, I, the manufacturer, built that watch. And they don't attach it to the watch because I think the name of the manufacturer is already written on the watch. But now it's basically also written on that NFT. So now I come and buy the watch. So then the manufacturer transfers the ownership of the NFT to me because I bought the watch. And that's it actually. It doesn't only transfer the NFT, so the NFT ownership now is at me, but the attestation is still attached to that NFT because the asset DID didn't change, because it's still the same NFT. It's in the same contract, it has the same ID, it's on the same chain. And so I can be sure and I can show off, I have that NFT, and it does not only say that I have that super expensive watch, I can also prove it because I have an attestation from the manufacturer which basically shows this is not a made-up NFT from that I issued to myself. No, it is really an NFT which was issued by the manufacturer. So this is just like a basic use case for asset DIDs, but I hope that perhaps the NFT guys here in the room perhaps might pick it up and just come to me and let's talk about that. I think that's a really nice thing that we could also incorporate within marketplaces. Yeah, and that's it actually. Thank you. Here is a list of stuff that we already built on top of Kilt. I was asked today if we are live. Yes, we are live. We are on Polkadot. We have like 6 applications built on top. You can just start creating your digital identity, put credentials to it, and start using it. There are already the first websites which accept login via Kilt. I think Apple looked also a bit like they are about to support it. Not completely from what I saw, but it looks like it, and it's going into the right direction. And yeah, so thank you. Last slide from our lawyer. It's no financial advice what I said to you. And yeah, legal note, if you want, please read it. Okay, then bye-bye. If there are any questions and time left, I don't know.
Yeah, it's okay regarding time. So just, one thing first. It's interesting that you mentioned you showed the watch on your presentation, because I think Rolex just entered like the NFT space, like they announced something like recently. So before we go to the questions from the public, I have one question for you. So what are you as a developer most excited about from the future projects? Okay, besides getting a Rolex.
I mean, I'm really super excited for just getting all our data back. So I really want to basically live in a world where I just have custody of all my data, where I just don't have to have a Google account to go to work. I just don't want it. I don't want those central authorities there. I just want to live in a world where I have custody over my data and where I'm not basically taken hostage by those big corporations. I just hope that we can do our part to break it all up and burn it down, basically.
Okay, so do we have any questions from the public? Okay, let's start there. You gentlemen.
Yeah. Right, exactly, yeah. Yeah, exactly. So, and I mean, just to follow that idea, basically, if I have a stolen Rolex and want to sell it to you, and you say, I will only buy it if you prove me that you own the NFT which matches that watch. I think you won't have knowledge about all the addresses that the manufacturer at Rolex uses to issue those NFTs, because those will also change over time and so on. But if the manufacturer, if they have a DID is like a long living thing. It's like the identity of the whole company. And if they issue a credential to that NFT, then you can be really sure it's not a made-up NFT that I only minted just to prove to you that it's not a stolen Rolex. But then you can be really sure, yes, this is not just a random NFT, this is an NFT which was issued by Rolex. And that's just the extra layer of security on top of there, which comes then from the attestations. I hope that, yeah.
Sorry, just a second. For the live stream, I have to repeat the question. So, to put it shortly, you were asking about the attestation for the DIDs? Okay, so basically, yeah, if you have the attestation only on your laptop, how to use it like once you're on the road, basically, you have only the cell phone with you.
So we don't have a protocol level solution for that, because that's just not our core business. I can just tell you how I do it. I have them just encrypted in a public Git repository. So I have like my GPG key, which is basically encrypting my stuff, and so I can just sync via Git between my different devices. So, but that's a very personal thing, everybody. I mean, you could also just use a centralized provider for that if you want. I mean, I have a GitHub account. That's not much better. But at least it's encrypted and it's accessible, and yeah, that's really the downside of being like the guardian of your own data. You have to guard it. There is nobody who does that for you. It's the same thing with your seed phrases for your accounts. How do you manage that? It's the exactly same question. So yeah, you have to think about how you back up your data and how you distribute it on your devices. We don't have a built-in solution for that, but I think that is something where we can expect to see some solutions.
Okay, so the next question was also there somewhere. Okay, so to reiterate the question, it was if kill DIDs are ready in case if the government decides to like implement DIDs or like in wallets, like use it like for example in MetaMask and like different wallets.
I mean, they would be usable for that, but we can't forget that we are just part of a bigger decentralized identity ecosystem. So Kilt is not the only DID provider, but we are the one which is the most major, I'd say. So there are a lot of DID providers, there are even some on Ethereum and so on, but I think we are really at a stage, also with all those advanced stuff that we can do. We can have a name, we can have service endpoints and so on, so we are actually ready for that. But I think the first part of your question was also about if they can force me to do that, or did I misunderstand it? So if some authority would come to me and would say, you have to use this technology, I would be very skeptical. And that's why we are building on a permissionless open blockchain. So they can't be forced, so we can't be forced to do stuff. It's just not under our control. It's a distributed system, and people have to vote for every one-time upgrade we do. And if there's a large government or so who wants to push us to do stuff, the community can decide, yes, this is good, then we vote for it, or this is bad, then they vote against it. So I wouldn't like to be forced to use a specific technology, but I'm offering to you all, use it.
Okay, so yeah, at this point I'm gonna stop questions because we are like way over time. But you can find Tino in the crowd and like speak with him directly. So thank you, Tino. Okay. Let's give him another applause because it was like really insightful presentation. So before we continue, I would like to just give one update. So apparently there are some issues with the toilet up there. But there is an alternative. There is also the map you can find there, which will show you how to get to the other toilets that are, you know, as a backup. So yeah, now let's go to the next speaker. who is more known under the synonym Alison Bob, but in real life his name is Tommy. So he's gonna speak about problems in DeFi. But one more thing before he goes into problems in DeFi. There is a big day for Mangata today. Maybe he can give us just a quick intro into what happened today. So, yeah.
I can mention it at the end. I will mention it at the end, okay?
Okay, perfect.
I mean, I'm so sorry to interrupt. I just love the stage, you know. I can be without it. So we got complication with toilets, with restrooms. Someone was already asking. So there is actually a map how to get there. It's like quiz, you know. We want to see if you can manage. And then you will see like signs outside where to go. Please use the door here, and then you just go to the left, and you pass the white car. You pass a lot of stuff to go there, but we put papers there, so just, you know, we are really sorry for it, but it's, yeah, nothing we can do about it, so.
Okay, hi everyone. My name is Tommy, also known as Alison Bob. I do communications, I do marketing, business development for Mangata Finance. And I titled the presentation today, Solving the Big Problems of DeFi. I like to do big, bold claims and try to pretend that I know everything about the world. But what I've seen today is, what makes me very proud is to work in the Polkadot ecosystem, because there are so many great projects and so many great people. And it's really such a great time to be there, because, you know, in the past they conquered the world and went everywhere to the world, and like people are everywhere on the planet right now. In the future we might go into space, who knows, but right now we're exploring crypto and this new space and domain, and it's a really exciting time. And so it's, for builders, it's a great time to build. So let's talk about solving the big problems of DeFi. So for those of you not following the news, we have a few centralized entities that are fighting for dominance. Here are two good friends. I won't be talking about the economic problems that we're seeing and the power problems. What I will be talking about today is more the, let's say, the technical stuff, or the stuff that we can actually do something about. And I want to start with this assumption that DeFi is broken. DeFi is broken. And what do I mean by that? Right now, a lot of DeFi originates on Ethereum and similar systems. And Ethereum was not conceived as a system for dealing with money efficiently. It was built as a computer that should run as a computer, and so it has a lot of assumptions that do not really work too well with DeFi. So let's call it the first generation of DeFi and look at a few of the problems that we at Mangata are looking at especially. So the first and most tangible problem is that you have high gas costs. So traditionally, when you're investing money, what you are getting as one of the very first ideas is $2 cost averaging, or whatever, euro cost averaging. So invest maybe, if you can, 100 euros, $100 per month into stocks or crypto or whatever. Now, if you buy on Ethereum for $100 per month crypto, you are always paying gas costs. If you have a low time right now, maybe a few dollars. In the last bull market, it was like $100, and if you chained 3 transactions together, it was $300. So high gas costs is like a very substantial problem, and Ethereum is not conceived to offer you cheap costs in this regard. It's conceived in a way to manage the resources it has. DeFi tokens have a low correlation with protocol activity. For example, Uniswap, it's a very successful protocol for swapping, but the unit token is just there for like off-chain governance, so it's not really connected to the protocol in any way. If you have ETH, you have to make the decision if you're staking it to secure the network or if you're using it in DeFi. So you have to make the substantial decision, and ETH cannot be used as a very capital efficient tool to you have to make a decision. So it's like splitting the attention of what the token can do. So this is the category of the economic inefficiencies that we're seeing and looking at. And then there are also misaligned incentives. And if you look at Bitcoin, one of the very subtle but ingenious things that Bitcoin was doing was that it was aligning the incentives of the node operators, the miners, and the people using the network by aligning the incentives in giving miners rewards in the stake, in the tokens of the network. And a lot of the stuff we are seeing today with all of the stuff that you are building is that we are looking at how can we align incentives. How can we align the incentives of attesters and users and verifiers and so on. So one of the biggest problems and one of the most corrupting problems in Ethereum that we see today is the problem of MEV. A few people are aware of it, but not everyone is aware of it, and it's actually a very substantial problem. And the problem is, let's say you're doing a swap on an exchange in Ethereum today, and you're trading a little bit of a larger amount. So what you always have to assume is that the price can change from block to block. So when you see a price on the user interface, the price might have changed in the next block. And so that you're not always getting blocked, like that your transaction doesn't fail, what you need to do is allow for a little bit of price change from block to block. You say, slippage is okay to me if the price slips like by 1.5%, it's okay for me. So now a bot will see when you submit your transaction, and it sees that you're okay with the thing being more expensive by 0.5%. So if the bot has a little bit of capital, it can come in right before you, because he might put the transaction before your transaction in the block, push up the price a little, buy a little bit of the thing, then your transaction comes in, pushes the price up even further, and then the bot sells the stuff that it just bought. Yeah? It's called front running. So the bot front runs your transaction, then your transaction, and then he back runs your transaction. And basically takes your slippage, steals your slippage. Front running is becoming a huge problem, and MEV is becoming a huge problem in Ethereum, because this happens before anything is committed to the chain. So when you're submitting the transaction, it goes into this mempool. This is like a storage of all the transactions that could go onto the chain. Now, there are a lot of nodes colluding, like miners, validators are colluding and looking at the transactions, and basically when a node gets the right to create the block, it sells off the right to decide how the block is composed to other parties. This is MEV, and it's becoming a big industry. Last year, there was $1 billion of value extracted from traders and from people who wanted to just interact with the chain. And it's becoming a whole industry, and it's corrupting Ethereum. The funniest and worst thing of all is, so the biggest entity that is doing this is called Flashbots. You might have heard of them. And Flashbots are offering also OFAC compliant nodes, so so like blacklists of people like Tornado Cash and so that are censored. So any OFAC compliant list is getting, any transaction coming from there is getting censored. So not only are they stealing from people, but they're also contributing to the censorship on Ethereum. So MEV is a huge business, and it's spreading to all the other ecosystems. So all the other ecosystems get infected with this idea. And the dominant narrative is that you can't do anything about MEV. It's happening because there are economic incentives to steal from people. So if we can't do anything about it, we are going to play with it. So this whole narrative, and it's very dominant in Ethereum, is about MEV democratization, which basically says, if everyone is doing it, it won't be so bad. We are basically mitigating the effects. Protocols are playing into this by basically saying, if people are extracting the value, then we should extract the value. So protocols are starting to produce outlets for MEV extractors to basically share the revenue a little bit. So if you're stealing, I'm making it easier for you, but you're also giving me a little bit of that. And it's insane. And the problem is a lot of people are accepting this narrative. The founders of Mangata were saying that it doesn't have to be that way. And so we are following the idea of MEV minimization. We would like to prevent it as good as possible, but it's like a super complex game. And so the approach we're doing is looking at how MEV is working and then trying to minimize the effects as good as possible. And we've found some good solutions to this. Okay, like this is a big problem, that's why I spent some time here. Next problem, mercenary capital. And you usually see this when there is a new exchange starting or something. There is like people that have a lot of liquidity come in, they farm all the incentives, like liquidity mining rewards, and as soon as the profitability goes away, they leave. And so you have this capital that is always moving around, trying to extract the value where it can do it the best. It's having this name of mercenary capital. I mean, it's just opportunistic and it makes sense to do it, but it creates instability for the user because the user cannot rely on having a certain degree of liquidity and basically have stable prices. As a user, you always have to feel an uncertainty if you're going to the exchange, if it will be a reliable service and experience for you. So, and I think this is a very important problem because like everyone who tries to participate in liquidity mining, usually if you talk with retail users, so regular people, they're getting wrecked. They're losing money in providing liquidity. And I think the biggest issue for this is that people are, understanding liquidity is super hard and takes a lot of time. I've been spending a year of my life now thinking about liquidity, and there have been many days where it was the first thing I was thinking about when waking up and the last thing when going to bed, like understanding all the mechanisms. I have a feeling I begin to slowly understand it, but it's like you can spend so much time on understanding it, and it's something where people just get wrecked on. So the founders of Mangata like to talk a lot about MEV, but what I realized as a marketing guys, they just like to think about a lot of problems. Like they like to think about and identify problems that are existing there and then finding solutions to them. So this is why the presentation is called like this, because we were just looking at all these problems and are developing solutions for this. So let's fix DeFi. My body's always shaking when I'm giving a presentation. Okay, so the end game. The end game of DeFi is capital efficiency. What does it mean? Yeah, so what is capital efficiency? It's a super important concept. It's one of the most important concepts in DeFi, and that is how much money do you pay to get something? And capital efficiency means you pay less to get more, or if you pay the same, like, yeah, you want to have like the lowest price to get something. Let's say you could buy some DOT today on one exchange where it costs, let's make an extreme example, on one exchange that costs $5 and on another exchange that costs $7. Yeah? You have the best capital efficiency if you pay the least and get the most. Now let's go back to the Ethereum example of high gas costs. If you want to do dollar cost averaging and you're paying like $5, $20, $100 for every transaction, it's not very capital efficient because on top of the gas fee, you also have to pay an exchange commission. So there is a lot of competition in DeFi protocols on looking how can we be more capital efficient. We were having this presentation today from AskRedDAO, and basically the claim was no interest rate and like very low fees. Yeah? It's very capital efficient, it's very attractive to you. So there's a lot of competition in DeFi protocols and finding ways to be more capital efficient. And we also have something to offer here. But because Ethereum and a lot of other ecosystems are capital inefficient in a way that they are producing gas costs or other things, you have to assume that in the end, in 5 years or so, 99% of the DEXs you see today will be dead, they will be gone, because there will be more capital efficient DEXs. And if all else is equal, you will go to the exchange where you pay the least or get the most. So that's why I'm saying the end game is capital efficiency. This is like one of the most crucial aspects. But the problem with capital efficiency is that it is centralizing. So one of the most capital efficient exchanges in the world is Uniswap version 3. Because, I could go into the details, let's not go there, but it is very capital efficient, and so it's centralizing in the way that a lot of liquidity goes there and a lot of traders go there. MEV is also centralizing because it's like creating capital efficiency for the people stealing the money. And so capital efficiency is super important, but it's creating centralization. That's why we call it Wall Street, because all the capital was centralizing to this place. So you have to counteract this. And the way to counteract this is if you add additional values. And you not only have a value of capital efficiency, but you also think about fairness. So fairness is hard to define, but let's make it simple and let's say fairness is at least creating a level playing field where all the liquidity providers are getting the same chances and where also traders get the same chances. So this is a little bit ambiguous, and so it's very much subject to interpretation. And this makes it less easy, because if you want to be the most capital efficient exchange, you look to implement the Uniswap version 3 model, you go look and implement the curve-like model. But maybe you have other values like fairness. So I think this is a summary slide. No, this is like a slide. Oh, yeah. Yeah, we talked about this, let's move forward. So, parachains to the rescue. This is the thing that Polkadot is doing really well and is doing really great, is that it can optimize for certain use cases. And you can change the rules of the game of how everything is working. So you can build your chain that has different rules that can be optimized for capital efficiency, that can be optimized for fairness, or whatever you think is a good thing. So it's our chains, it's our rules. This creates a lot of opportunity, this creates a lot of innovation, it will create a lot of problems, and it will create a lot of drama in the future. I'm hoping to see that point in time, but it's also creating a lot of opportunity and optionality in this space, and it makes the whole system more expressive and powerful. So it provides us with the ability to fix bigger problems. So this is what Mangata sets out to do. And so this is how we are positioning ourselves now. Mangata is the DEX of Polkadot. We know that there are a lot of other good exchanges, but it should express one idea. It should express the idea that we're focusing on one thing and trying to do this exceptionally well. And this is also a thing that you see in Polkadot, is that you have very specialized parachains. And some people are questioning, is it really a good idea to make like such a specialized service? Do you need decentralized identity? Do you need like a chain just for zero knowledge proofs? But the thing is, the teams can focus and specialize on just that thing and do it really well. And so we are focusing on providing an exchange that really makes the exchange experience awesome and great. And the great thing is that Polkadot allows us to interact with each other. So, a few design goals we set up for Mangata. It should minimize MEV. It should optimize for capital efficiency. We want to maintain an equitable and level playing field. And of course, it should have an economically viable business model for the chain. I'm finishing just in time. So I could talk an hour about this, 20 minutes about this, half an hour about this, and maybe half an hour about this, but I won't because they don't give me the time here for this. But the interesting thing is, so this is basically the layering of a blockchain that you're getting. On the trust layer, what we are adding is that we're not doing a proof of stake system, but we're doing a proof of liquidity system. So what it does is, you're not staking native tokens to produce trust, but what you're doing is you can stake liquidity. And what it does is it unlocks the capital efficiency of the native token, which is on Mangata X, on Kusama it is MJX. On Mangata it will, so on Polkadot it will be called Mangata, it's MJA. And it unlocks the capital efficiency because the token is not staked and unusable, but it is acting in liquidity. So our native token paired against another token in liquidity is creating the trust and you have to add more trust assumptions here and basically make the system strict in a way that you can still maintain the security. But it unlocks the capital to be also working on the execution layer in the exchange to provide as deep liquidity as possible. Good. On the consensus layer, we are adding a new thing. So usually consensus means there is no double spend or people like spending tokens on different things, or like consensus means the rules that the chain implies that you have to follow. And the trust layer secures that the consensus will be held. So what we're adding here is Themis architecture, which is a new protection against economic, so it's adding economic security in the way that we built a mechanism to prevent front running and MEV. I don't have the time to talk about it, but you can find a full blog post and a video on our blog. If you're interested in how we change block production to be more complex and more fun, you can look at Themis architecture. And since my time is running out, we're doing gasless swaps, and it's not like just a funny claim, but we looked at the cases, we modeled the cases, and we can provide gasless swaps in most of the cases. Algorithmic buy and burn connects the economic activity of the chain with the value proposition of the token. So with each swap, a little bit of the native token gets burned, bought and burned. And time incentivization is a mechanism that basically increases your liquidity mining rewards over time the longer you provide liquidity. So it should create calmer liquidity. The liquidity doesn't move as hectic. And all of these things are designed to work together in a way that creates deeper liquidity, more capital efficiency, and still maintains the fairness for the users. So last slide summary. Where are we going at? We want to fix DeFi with all of you together. Mangata is the DEX of Polkadot. Will be in the future. We want to give exposure to Web3 projects because usually they're not so experienced in DeFi and what you can do and like how you think about liquidity and all those stuff. They want to build the cool Web3 projects. So we want to give them access and like make them economically accessible to the ecosystem. And we want to bridge to all major ecosystems so that we can list all the tokens. Today, Imbio launched. And if you want to list your token on Mangata, you can get in contact with me. You find me on Twitter, Edison Bob. And that's it. Thank you.
1, 2. Do you hear me? 1, 2. Okay, yeah, that's better. So yeah, next time we're gonna make an event only for Tommy to take us like to deep dive into DeFi. I'm pretty sure we could all learn a lot. There's one thing for sure. Next time that I'm gonna be messing with DeFi, I'm gonna give Tommy a call first because there is so many little things that I'm pretty sure most of us don't even know about it. So, do we have any questions from the public? Okay.
Give him the mic.
1, 2.
Thanks. I have a question about providing liquidity. You've mentioned really nice reason for trading, that it's cheap, zero cost for transaction, and because of burning. The burning is it's meaning that the trader is losing the amount what is burned, or the providers of liquidity lose the amount what is burned. And why is let's say profitable to be there for liquidity providers?
Yeah. So you're talking about the buy and burn, right?
About liquidity providers.
Yeah. Okay. So most exchanges have the model that every trade costs 0.3% exchange commission. And then is the question what do you do with the exchange commission usually? So some models give all that value to the liquidity providers. We are splitting it up into 3 components. So 0.2% go to the liquidity providers. That's basically what they're earning on providing liquidity. 0.05% go to the treasury. So the protocol is earning revenue and can do something with the money. So 0.05%, what is this? If there is $1 million in volume, $500 go to the treasury, $2,000 go to the liquidity providers, and 0.05%, $500 go into buy and burn. So it means there will be MGX bought on the market and burned immediately. And it is an additional incentive for MGX holders, and it also opens up the system because we have a hard cap of tokens. And so at some point, you would be running out of incentives to give away. But if there is, the volume is continually burning tokens, you have also like an infinite source of incentives to give out. Yeah? So by combining these mechanisms, it's like a really elegant system that can combine a lot of design goals. Yeah, I hope this answered it.
Yeah.
Okay.
Thanks.
Okay. Any more questions from the public? Okay, so now we're going to have a short break, like 20 minutes. And after the break, it's going to be the final thing of the day, if we take out of the account the after party. But the panel discussion, which with the topic of parachains versus smart contracts. So see ya at 5:45 right here. Thank you. We're going to start in approximately 5 minutes-ish. The final stage of today's program, which is the panel discussion with the topic part chains versus smart chains, smart contracts. So the panel discussion will be moderated by Peter from Polkadotters. The panelists are Tommy from Mangata, Tino from Kilt Protocol, and Annette Rolikova from Ethereum Magicians. I hope I got it right. So just one thing before we begin, regarding the after party, you can find the link at the Twitter profile, .brno or .sama Prague is the handle. So, because there were some questions regarding the location, so you can get all the information there. So you guys ready? Let's rock and roll.
Yeah, all right. So, hello everyone. I'm Peter from Polkadotters. We are like international Polkadot community and also validators and collectors in many .sama projects as well. So, welcome to our discussion panel. So, we will be talking about Polkadot parachains versus smart contracts, what are maybe some advantages and disadvantages of both approaches of developing decentralized applications. So welcome guys, and first of all, how are you doing today? Like, are you enjoying the conference?
Yeah. It's been doing very well. Thank you for inviting us. I'm sorry. Yeah, that was like MEV trade. So yeah, thank you so much for inviting us. It's been going very well, and I hope that everybody's enjoying the conference as much as we do.
Yeah, all right, great to hear that. So maybe I would start with the first question. So maybe we can go from Tino and do a round. So maybe if you guys again can introduce yourself a bit. And also I would like to ask you, since you both work on parachain projects, like what made you go to the Polkadot in the first place? Why didn't you choose, the smart contract approach being deployed on Ethereum or maybe some layer 2 like Polygon? So what was your primary motivation?
So first, thanks for having me. So what was the primary motivation to go to Polkadot and also build a parachain and not we could also have built everything we built as a smart contract on Ethereum, but as we saw, gas prices are unpredictable. Basically on Ethereum, they just depend on in which phase of the circle we are, and it's also generally higher gas fees if you do stuff on smart contracts, and we wanted that everybody could have a digital identity and not just people who, I don't know, have like $300 to buy the storage and to do that on Ethereum, but it's just way cheaper to do it on a parachain. And that was our main motivation, to have it really ready so that everybody could use it.
Yeah, all right. So the primary motivation was basically the gas fees. Yeah, all right.
And just one more thing, it's also way more flexible. So we just have, in Ethereum, if you don't know who already wrote a smart contract, you don't even have a double map. So you can just write code as you want to write it, and you are not in a fence which basically prevents it. It wasn't me, yeah?
Just hold it closer to your mouth.
Closer? Yeah. Like that. That's close.
Yeah, all right, thank you. So, Tommy?
I think if you read the Bitcoin white paper, it's hard to not get excited about crypto, because if you read it, you understand that there is something fundamental changing. When I was first reading about Ethereum, I was reading about it and I said, oh, this is a virtual machine on the blockchain. It's basically they're building a computer. They're building like a computer that runs on the whole world. And it's hard to not get excited about this. And for Polkadot, then this separation of concerns that you're building a system, but it's not tied to having a single computer doing everything. But it's like when you're building a computer and you have a graphics processor and a CPU and a storage, and you're building out these different components. And this is what parachains are doing, so it's really hard to not get excited about this.
Yeah, actually also think that application-specific blockchains are really the future, because in that way you can develop specifically tailored applications, within their own chain that can be really, really efficient and cheap in the same time. So, yeah.
Ethereum has layer 2s, for example, for that, and that's why we have modular blockchain solutions on Ethereum. Especially as Ethereum recently switched from proof of work to proof of stake. So right now, actually many projects are building on the top of the EVM, the Ethereum virtual machine, and that's how we are enabling the cheaper transaction, and that's how the Ethereum, or that's how we can use the Ethereum much more cheaper. So I know I'm
No. Yeah, be the devil's advocate here, That's definitely your role in this panel.
So it's like modular blockchains are doing basically the same as parachains, I believe.
Yeah, in a sense, but I would say, are we there yet? Because mostly what we can see, you know, in regards to layer 2s on Ethereum are another like EVM blockchains, basically. So that would remove the, you know, gas costs from an application, but it wouldn't allow you to develop, you know, your own application-specific blockchain. Like, or is it already happening on Ethereum?
Yeah, you can do that. For example, like Celestia is a project which enables you. It's like the data layer for the Ethereum. So it's like, as the Ethereum is right now proof of stake, so it has a bunch of shards, and then all the data will be basically stored on like different shards. And for example, I mean, most likely we will use Celestia for data as a data layer for blockchains, and so there it's usable already. And there are many other projects, for example, like Fuel. It's becoming pretty popular, that has Fuel VM, which is on Rust, which is written in Rust, and that's how we can even like right now build on the blockchain itself, on the Ethereum itself.
Yeah. All right. So maybe guys, some opinion on that.
I feel like we are both like very different like spaces, and this panel is very like Ethereum comparing to like Polkadot, and so we may get some fires going on.
I think there is an interesting project in Ethereum going on right now, which is called Eigenlayer. Have you heard of it? It's basically, it allows you to do restaking. So the ETH that you have already staked in Ethereum, you can basically add additional risk by reusing the same stake and staking it for projects that then can use the stake to add more functionality to Ethereum. It's pretty cool. Yeah.
I mean, it's obvious that some solution like this will eventually emerge. I'm just probably not that updated, or like, you know.
Yeah, like I would say the thing is, you know, it may be going to happen in a few years, but you know, when you see all those chains being developed on Cosmos and on Polkadot right now, you know, and that tells me that the technology behind that is really mature right now. Like you can really build your own parachain with Substrate. And it's actually getting easier and easier over time, and there are like a ton of teams, you know, doing that right now. So I'm not really sure, you know, if that the same is happening, you know, with layer 2s and Ethereum.
I'm just hoping that the Ethereum community won't hate me for saying this. But okay, I personally think that Ethereum is becoming to look like more like a Cosmos itself, and less of like, you know, because like Ethereum was designed in a bunch of different ways, and we went through it went through like a bunch of different designs, like how it will look like when it turns to proof of stake, and it seems like based on the last designs and based on the last Ethereum roadmap, that Ethereum the core design will look alike more like Cosmos than what was before. Like the design itself that was initiated at the beginning of like doing something like very custom and very special. So right now it's going to look like more like Cosmos itself.
I think that plays into the thing. So the originals of Polkadot are actually that Gavin Wood was just not satisfied with the current state of Ethereum, and then he just left and basically designed it in a way as he thought it would be right and better. And so Polkadot in itself started already with all that design decisions that got influenced by the stuff that happened to Ethereum. So it is like an evolutionary step forward, and it was also used basically to get rid of all the technical debt that, I mean, every software project has like technical debt that just accumulates over time. So that's why I'd say with the invention of Polkadot, basically, it was just like a cut zero, and it's basically targeting not the same thing, but it also wants to provide like a one-time environment, like a world computer, but in a more specialized way. And I think this is the big advantage of Polkadot. And yeah, that's just the history of it.
Okay, what do you think about the validator process? Because I personally feel like almost all validators are run by Gav, or like by like Web3 Foundation and parity. So what do you think about that? Because I feel like, because I mean, I did not look personally into Polkadot for a while. And from my last information, basically that the validator need to be approved by council, but council is just like a very close circle. That
No, it's not true at all.
Okay.
It's like completely permissionless, and currently there are 300 validators, and most of them are from the community or from the big companies like Binance or whatever, like on every chain.
But the validators need to be like approved by the council itself.
Well,
maybe it was like this in the past. I was recently looking at the chain and I saw some pseudo calls from Gavin, like way in the beginning, like 1,000 days ago. So there was this bootstrapping phase in Polkadot where initially everything was like fully permissioned, and there was this pseudo. And then over several stages they gave up the control. So right now Polkadot is fully permissionless. So for example, I ran a validator and it was fully permissionless how I came into the set. Maybe to the point where Ethereum is strongest and where Polkadot is strongest, when I publish a smart contract on Ethereum, I can make it immutable, so it cannot be changed. And you cannot do anything like this in Polkadot and Kusama, because every parachain has the possibility to go out of service, no longer renew its lease. So the thing where Ethereum is best is if you want to have something really immutable. What Polkadot will do, so on the other side, on Kusama and Polkadot, you have like the other extreme in that you can have a lot of flexibility in a way that you cannot have in an Ethereum right now, because you can decide on so many aspects. And there is like maybe this convergence where I'm not sure how this exactly works, but these trusted execution environments, I think they are about adding something immutable to the system, but I'm not 100% certain.
Actually, not so sure about it either, but maybe one thing to add, from what you have already mentioned. And the thing here being, like you said, smart contracts are immutable, but the nice thing about parachains is actually they are upgradable, right? And they are governed by the governance bodies like the council and like the community, and actually if some referendum is voted upon, and is being approved, the upgrade is done automatically, on all the nodes, and the chain and the logic of the chain itself is being upgraded this way. So that actually makes really, really nice and smooth for both developers and for users of the applications as well. Then you can actually upgrade the chain even quite often, but the users, are noticing that. So I would say that's really one of the nice advantages as well.
But to be fair, that's also possible with smart contracts. So you can also just like deploy a smart contract which is immutable, but then you just create a proxy smart contract in front of it, which just has all the methods, and then you say you write just in the storage of that smart contract here, actually your implementation lives there. And then it just calls out, and then you can also have like a DAO which decides to upgrade the logic, deploy a new backend contract, and then just swap out that address of that contract. So it's not that smart contracts are not upgradable by default, it's just more effort. So,
yeah. All right. So maybe now like more general question, like when do you think it's like necessary or like really suitable for application to not be a smart contract, but actually to become its own blockchain, like be it parachain or zone on Cosmos or whatever? Like, where do you think is the line or the border, for application to become its own blockchain?
So I think it has a lot to do with volume. So when you have an application which has like, I don't know, 100 users or so, it doesn't really make sense to run it as a power chain, because you won't be able to run it over a long time because of the power chain concept. Only power chains can survive which are economically successful, because they have, and so at first they have their crowd loan, I mean most of them, and then they have their first lease, and in that first lease they have to prove that they are economically livable, basically, that they can live on their own, because if they can't, they don't have money for the second lease. So that sounds cool, basically, to the poor power chains, but in the end we will have good power chains which are useful for the world, and because they are useful, they are used and also make money because of that, and that's like a circle which just always continues. So it's not bad that power chains can go out of business. They will go out of business when they are not relevant anymore, and then they make basically place for new power chains and new projects. So that's why it's not that bad. Let's say it like that.
So yeah, so basically, in Ethereum, it's very much like free flowing. Like anybody can deploy smart contract, and anybody can create their own company. Anybody can just like decide to build a project, and nobody really like cares. But comparing to Polkadot, you need to be picked, and you need to get the parachain slot in order to build your project, or you can build it on Kusama, I believe.
I mean, you can also like just create a project for 100 users, but then you won't create a power chain. Then you will just write it as a smart contract and deploy it on Moonbeam or on a Star or so. So it's not that in Polkadot you can't have those small projects where nobody cares. We also have like those execution environments for smart contracts. So it just opens up the possibility to scale that out. So you could start with like a smart contract and 100 users, and then when you see, okay, this is really, I just hit it. I just found out the nicest solution ever, and then people will jump in, and your user base will grow, and at some point you will have a community which is so hyped that they will just throw their money at you and say, here, take that money and buy a slot. So, and then you can just upgrade it, can take less fees from your users because it's then less expensive to execute their requests. And so there's a nice upgrade path from a small project to a big power chain. And I think that's also one of the powers of Polkadot.
Are parachains more controlled than the execution environment?
Yeah, you can change everything. You can, for example, you can present a bear case for a parachain, which is when you're not sure if you should build a smart contract application or a parachain, you shouldn't build the parachain because you not know what you're getting into. Like
rule of thumb. Yeah.
If you can build it as smart contracts, it's okay. Parachains they are more complex, like they're at least 10 times the effort, but they give you more guarantees. For example, if you build smart contracts on Ethereum or any EVM chain, you're competing with all the other smart contracts in the same execution context. So, system. Yeah. So when there is a new NFT mint and the chain is full with transactions, you basically have to wait if your users are not willing to pay the gas fees. Yeah? While when you have a parachain, you basically have a secured allocation of block space.
So it means that, but are parachains interoperable between each other?
Right. So they can open a channel. It's like a communication channel, and then they can send messages. So the most simple message is, I send you X tokens.
So it's like you can exchange tokens between parachains if they agree to open a channel between each other, or you can just like say like, oh, I have a project XYZ on parachain 1 and I want to send metadata to parachain B, but can you just like send it right away, or do they need to just like both parties agreed of like opening channel itself?
So they have to agree. So parachain 1 has to open a channel to parachain B, and B has to open one to parachain 1. So it's not a bidirectional channel, it's like an unidirectional channel, and they just all have to agree. And also there needs to be logic to accept those messages, and also logic to send those messages out. So it's always like it's a combined effort between those two parachains who wants to exchange messages.
Governance.
Yep.
So, but maybe on the other hand, I'm not really sure, because nowadays the protocol for exchanging the messages is called XCMP, and now we've got version 2, right? But I think with version 3, actually, that changes that. The parachains actually don't have to communicate through the relay chain. And also, I'm not really sure if they will need to open the channels, you know, like they actually need to do it now.
So what kind of messages can you send?
Yeah, and actually that was the question I was going to ask, because in the future it will be possible to send like any kind of message, to call like any kind of functionality from one parachain to another parachain, and actually you can go even as farther as, you know, like from one parachain calling actually a smart contract deployed to another parachain. So if there is, for instance, EVM on the other parachain, you can call a smart contract on that EVM. And so that's actually the question, you know, I wanted to ask, like if we can achieve the same level of interoperability that we already have on EVM, because like any smart contract can call any smart contract quite easily. So can we actually compare XCMP to that, or maybe not really?
I mean, we are not quite there yet. So what we can do now is send a message from chain A to chain B. But what currently doesn't work by now is like doing a request response pattern. So we could emulate that, but XCM messages are at least currently fire and forget. You just send it, and you get the guarantee that the receiving chain gets the message and will also process it. But you will not know if it fails, if it was successful, and so from my point of view, the most annoying thing is you can't query state. So other chains can't come and look up a DID in the kill chain, for example. And this is something which is currently improved, and I really hope to see that we will have like request response XCM messaging, but this is like in active development. So I think, I'm actually not sure, but I think between two smart contracts in the same execution environment, you can just call them and get a response. Yeah, then yeah. But this is where we really have to work on. So, but yeah, the rest is already working.
Getting there.
Getting there, exactly.
Maybe, I'm not really sure. I don't think the channels get discarded. I think channels are still a thing. And it's basically introducing this component that parachains can decide with whom they are opening a communication line or not. And yeah, they are fully configuring what they are doing. So if you're sending tokens, basically both chains have to agree what it means when there is like information sent. But you asked what messages can you send? You can basically send any data, and they just have to agree what it means. Similar to how your phone is connecting to the internet. It's more like parachains are like apps on your phone. So the phone is the relay chain, it's like Polkadot or Kusama, and the apps are the parachains in a way.
Yeah, all right, thanks. So, and maybe one more idea actually. Like, is there something when you were guys developing, you know, Killed or Mangata? Is there like anything that would be really hard to do for you if it was a smart contract, but was actually quite easy, you know, doing it with Substrate? Like, have it like ease in your development, you know, in this way by, you know, making it its own blockchain and being able, you know, to put there any kind of logic, you know, as you want?
You could decide to not charge gas or treat it in a different way. What a parachain also can do is, so, yeah, okay, now I can do this one.
There's one thing that I couldn't do on a smart contract, and this is controlling the deposit cost for storage. So whenever you write something to a blockchain that's retrievable by others, you occupy space on that blockchain. And to incentivize that you clean up afterwards yourself, you have to put a deposit down, which corresponds to the amount of space that you are allocating on the chain. And when you then do an operation which removes that data from the chain, you get back your deposit. And on smart contracts, this is, I mean, I know that for a star and in contracts, there is like an auto deposit. They basically measure how much space you take, and then they deduct that deposit from your request. If we, for example, on Killed, would have the same price for deposits than Polkadot has, so the relay chain, a DID would be around $200 of deposit. That's like a lot. But since we are a private chain, we could just decide it. Like Mangata can decide to not charge any fees for transactions, and we can decide to just take less deposit, for example. So, and this is the freedom that we get by having our own chain in contrast to being tied to a smart contract environment.
There's also one very generic thing. Each parachain can do autonomous transactions, so it's not triggered by a transaction from a user, but the chain itself can have rules on when a certain transaction gets triggered. And for example, what we're doing with Mangata is we're changing the way how blocks are produced and how transactions are getting included in a block. So basically, it is not in a single node that is basically executing the transaction, but the first node accepts the transaction to the block, and the second node applies a randomization about the order of the transactions. Yeah? So you can change the consensus rules, and you can change the trust rules below it.
So that's basically how you prevent the MEV, right?
Right.
Also, with IP 4844, things will change a little bit on Ethereum. In regarding the space, how we will determine how much we will pay for the space, and then the blocks will be much more easier, like much more predictable how much will one block will cost. So that will change. I'm not sure if I should go into deep of what's IP for A44, but it's about...
Well, you definitely can.
Okay, so it's about like sharding. And maybe if you guys saw the meme with the blob, so basically AIP4844, it's also called proto-dung sharding, and this AIP introduces that we will use blobs, and blobs will have like specified number, like how much blobs will be stored in a block. So there is currently proposed between 8 and 16 blobs will be in one block, so it will be much more predictable. And then also blobs will store data, not the transactions. So then the transactions will be stored by, let's say, like Etherscan, but then the blobs will be stored just for like 1 month period, and then they will disappear. And also this creates a huge opportunity for gas market.
So does it mean the blobs are like each shard is creating one blob? Is the idea you have different shards? Okay.
Yeah, each transaction creates blobs. So there will be blobs inside of block. Sounds very complicated. It's not.
And is it something you can actually customize as someone who is submitting the transaction? Like, you know, how much you will pay for that blob, you know, and how much it will cost to actually store some data over there, or this is like governed by the Ethereum protocol?
There will be gas market for that. So there will be like a special marketplace for determine how much is one blob.
Yeah, because I would say that's the difference, you know, in comparison to parachain, where you actually decide, you know, yourself how we are going to store the data, and you know how much are users actually paying for it. So maybe, like, you know, Tino mentioned actually with the guild.
But not every transaction is the same. And it differs all the time, whether you send like tokens or whether you send NFTs. And also different NFTs have different kind of like amount of like storage with itself. Yeah. So there is like so many factors that you need to, so many things that you need to factor in order to like how much each transaction costs. Especially smart contracts are very customizable, so anybody can like write smart contracts basically, and they can like, you know, send out transactions. And then there are a bunch of ways how to optimize transactions itself, so you can make transactions cheaper.
When you're talking about this, since you're talking about proto-dank sharding, is it like laying the foundation for sharding, or are there then already shards?
That's mainly for layer 2s actually. So like layer 2s will be using this prototype sharding concept.
So when you talk about the gas market, so they can they buy a blob and then fill it?
No, like every transaction will have a blob.
Okay, but you said there are like 8 blobs per.
They will be between 8 and 16 blobs per block itself,
Okay.
and that will be determined by the size of the transaction itself. So like how much data will you have to send with the transaction itself, then based on that will be counted.
Okay. But those 16 blobs would just go into a block of a L2, right? Because if there would just be 16 blobs in every Ethereum block, it would be like not enough, right?
For validators to add more block space so they can store blobs as well. So I assume that it will be on main chain, not on.
I'm just thinking about the throughput. So if you can just do 16 transactions per block, it would be like, I think I misunderstood that.
No, it will be just for data.
Just for data. So
yes.
normal transactions are not included there. Okay, that makes sense.
And also they will use polynomial commitments for like getting the data out of for like.
So it will become a blockchain then.
Yeah, that's that's the main.
And actually, since we are talking about the data, like does parachains and substrate, makes any easier for you to store the data, like via like off-chain transactions and stuff like that? Like, are you actually guys using that in your projects or not? Not really.
I mean, I don't know if this is what you mean, but storing data from a developer's perspective is much easier doing in a palette than in a smart contract, because you are not tied to just a few data types. You can just use everything you can compile down. So you can have maps, you can have bounded vectors, you can have the wildest data structures there, you can have tree structures, and you can just have them implemented there. You would have a hard time to implement those data structures in Solidity. So that's really like, so for me that's like one of the killer features, that I'm just not tied to just specific data types, and that I can just freely program and define my logic and don't have to care too much about the execution environment. That's if you talk about storing data. So for me as a developer, it's super convenient to store it from within the palette, in contrast to from a contract.
So it basically means you don't have to conform like any format that is dictated to you by the platform we are developing in, but basically you are making the platform, so exactly. You can make it safe any kind of format you actually want.
Yeah, you can do what you want, and you are not. There's nothing which prevents you from doing what you want. And in Solidity, it holds you back at some point.
Yeah, I guess that makes sense. And we already briefly touched this topic, but actually, are you guys taking advantages on being able to set your own tokenomics and your own fee and gas models, which is also, I would say, difference between having your own independent blockchains in comparison to having any kind of smart contracts, because obviously you can optimize smart contracts for gas. But on the other hand, when you are developing your own chain, you are like completely free, in doing anything you want. So maybe what's your opinion on that? And you can actually answer as well, Annette. Like, what do you think about this? Like, if this is something that makes sense or not actually so much?
I mean, you can always design your own tokenomics, and you can like always do whatever on Ethereum. I don't know. I think that's probably a better question on my other friends, my other panelists, as they are building on Polkadot itself. And I would love to see probably Alice and Bob to like answer us from Mangata.
Okay. We're talking about tokenomics?
Yeah. Yes. Like how did you guys design tokenomics itself, or like what's the design process of the tokenomics?
Yeah, and actually the main thing I was asking, how can you take advantage of being your own sovereign blockchain when designing your tokenomics? Or
Yeah, I mean,
gas model, and fees and stuff like that.
yeah, sure. I mean, you can describe, for example, so what Akala is doing and what we also are taking inspiration from is that they built this bring your own gas model where basically if you don't have the native token, the chain accepts the other token if it provides the same spam protection. Yeah. So you can find, I guess, quite a few genuine use cases. On the other hand, I think for some chains you see the same, how do you say, not optimal tokenomics, where they are not. So there's a certain amount of use that your chain will see. And if your primary value proposition is the gas fees, but you will have just like a limited number of transactions on the chain, you just, this is like, will not make up the value of the token really. And then, of course, you can have governance value, but tokens need a strong value proposition and they need a revenue model in most of the cases, at least when people are seeing them as a thing to profit from. Or what we might see is that actually when block space gets more dynamic, that maybe chains will just have like a much more reduced allocation of block space and might be just like taking a more tiny slice because they don't actually need so much block space. But I think this is something we will explore more in the future.
From Ethereum perspective, I feel like you can always like do whatever with the tokenomics itself, and you can like always design it like super advanced, or you can just like go even beyond the limits of the blockchain itself, and then design some custom smart contracts. But then in the end, you may get hacked, and there are so many smart people that are looking into smart contracts like all day long, and there are literally people sitting on the Etherscan and like just like watching the code itself and just trying to find the exploit itself. And when it happens, then it hurts the users itself, as they will lose a lot of money.
Yeah, but on the other hand, the gas model is given, right, on Ethereum. Like as a developer, you need to conform with that, and there's not much you can do about it. Like, I mean, you can optimize, obviously, but like when I submit a transaction, it will cost me this and that, and there's not much I can do about it, right? Like maybe, depending on how much traffic is on the chain right now or how much the block space is getting filled, that's not really you can take advantage of, right?
So if you're talking about gas cost, that can be definitely reduced, but also there are things like MEV that somebody can like front run your transactions, like, right? So you need to be always careful, but what's the best sort of like security practice? I would say that's audits. Like always audit your code before letting your users to put money in, and that way you can prevent you can like mitigate the risk of people and your users, your valuable users, to lose money.
And it's becoming an industry standard, right? To get audited before you go live. I guess most of the projects are hopefully doing that right now.
Be careful when you are investing into new token, basically. That's like my best advice.
As a general advice, yes. Regardless of the chain.
Or based on what happened over past couple days on crypto Twitter, be very much careful where you put your money, and especially when using exchanges, whether that's centralized or even decentralized exchange, please be careful. And if you are using centralized exchange, try to like use it, but put money in, trade, and then take it out. So you are like minimizing the risk of losing money.
And also, I would say the DeFi is getting more and more mature, these days. So actually, there's not so big need, for centralized exchanges as it used to be, like 2 or 3 years ago. So.
I mean, SPF is a fun guy, And I think he just put up some Twitter thread where he apologized, but you never know who handles your money on behalf of you. And our favorite thing to say in crypto is not your keys, not your money, of course. So be mindful.
What I think is also important when we're talking about risks, as we're progressing and we're basically now seeing like more real DAOs, so real on-chain organized organizations. And I often like to say that parachains are DAOs out of the box, but it's not really true. But they can be DAOs out of the box if you would give up the full control. But most parachain teams, and I think rightfully so, decide to maintain the control initially. And the thing is that governance attacks are a thing that we need to keep in mind. Will be like, I think in the future we will see much more attempts on governance attacks. So we see this on Ethereum. We are also seeing it in the Polkadot ecosystem. When, for example, there was one very elegant governance attack where someone was like doing a flash loan. I think it was a flash loan of tokens, loaning the tokens on some protocol, making a governance decision initially, immediately accepting the governance decision and, I don't know, stealing some value. And I think, so we are seeing this basic risk from centralized entities, but just because something is decentralized doesn't mean it's free from the risk, because if you have a DAO, it is an organization. An organization has control. So we need to...
We have a guest here.
We need to find models to... This is like the second level complexity. Did you plan this?
No. It's just like buried in its own thing. She's just like, hosting its own conference.
Yeah, but this is like, just because something is decentralized doesn't mean it's safe. Yeah, we're still having an organization that can be attacked, and so this, especially for DeFi, there is like this this asymmetric risk where it's like less risk to use money to try to overtake the governance, and especially if it's DeFi, there's a lot of money to take out, right? So I think this is something we will need to talk more about in the future.
And so do you guys consider one of the advantages of parachains that actually they usually comes with the governance by default, because there are substrate modules for that, and most of the chain are using it in some way or another, because usually there's a council, usually community can vote with their tokens, and that's how it works on most of the chains. So how do you see that?
I mean, most of the chains have that governance basically, and it's also supposed to be like a decentralized system using that governance.
But it's not often.
But it is only as decentralized as the money is, actually, as the tokens are distributed. And what's even more crucial, that the people who hold the token actually take part in the decision process. So when I look at like treasury proposals, for example, sometimes there is like a turnout, so like amount of tokens from the total supply which were used within that vote of 0.5% or so. That's just not a decision. That's like 3 people who voted. Like 2 people were in favor and 1 was against, and the one who was against had 3 times the amount of money, and then the decision is discarded. That's just not democracy.
That's a problem of incentivization on a governance level, on like the protocol level, like how, then we can like, it's more of like a question how protocols should design their governance in order to incentivize users to vote and participate in the decision making of the protocol itself. And that's like, this is a much better question than just being like, oh, there was like a proposal and only 3 people voted in. That should not be.
But this is actually something where we have to get better. So it's also, from my point of view, it's also not the best idea to take the amount of money somebody has to calculate their voting power. Doesn't sound like a good idea in the first place, but I know that it's like the best thing that we currently have, because we can't say for sure this is one person who votes, because we are in a permissionless blockchain. That one person, which owns perhaps 1,000 DOT, could just create 1,000 accounts with 1 DOT each, and could then have 1,000 votes. So somehow we need to make sure that any amount of money, basically, so we have to make sure somehow that the power is distributed and that not a single person can basically pretend to be like 1,000 persons. But so the best solution that we currently have is voting with the token power that we have, and then perhaps with conviction and whatever. But this is really something where I'd like to see some progress and some sorts. So because from my point of view, it's not really democratic. It's like if we would let the big corporations with the big money decide who will be our government. That would be like kind of dystopian, but currently in blockchain, this is the best that we have, that we can vote with money.
I mean, you can see that already happening in like the states and like the government itself.
Yeah, I mean, if you look at the states, yeah, and also in all the other governments.
Corruption and all that.
Yeah,
happening.
I mean, it is already now in real societies like that. That if you have like enough money, you can make more advertising. You can make like a big campaign, and then people will vote in your favor. But still, in real life voting, basically, you have that there's one person has one vote. If you have much money, you can use that money to convince more people to vote in your favor. But the decision to vote in your favor is still at the people. But yeah, in Web3, we basically keep out that step of convincing people. We just say, okay, yeah, here is a person with like a super huge stake, and then they just have that voting power. And yeah, that's like a fundamental problem we need to solve. But
you should make also the tokenomics the way that it will incentivize its user to participate in your governance. And also, I feel like this is probably the issue that we have with the community itself, that we should make sure that our community, or like, you know, probably even like grasp the community when we are building it from the beginning and from the roots, to like make them used to participate in the governance and to like sort of like incentivize them. Like, yes, you will participate in voting, but then, for example, on Ethereum, many people are using POPs as like incentivization model, like how to make sure that users are voting. And then when you have certain amount of tokens or a certain amount of POPs, then they can give you something else as like sort of like gratitude or something.
I would say this is the thing we really need to explore, you know, how to like incentivize people really well in governance, you know, but not at the expense of the protocol.
I think
yeah, it's working, all right. Yeah, that was it actually, so go on to me.
I think also the thing with governance is also it's about politics, but it is not a, so it is a political thing, but it's not a democratic thing, because it's not one person, one vote. And so, but there is more to politics than just democracy. In this case, it's like very capitalistic. I don't know if it's just pure capitalism, but the thing we need is a governance culture. And every DAO and every protocol that is saying we are now a DAO and we are having governance, they have to realize that this is a cultural thing that you have developed over time. So you have to come to a point where there's like a centralized actor having the control, and if they want to give up the control, it's about how can you onboard people to participate in the process. And politics usually is something that you have to afford. So you have to, not everyone can participate in politics. That's the traditional problem that you have in politics, is that most people don't have the time because they have to care about their own stuff in life and cannot take care about politics. And if we are now doing the same thing on chain, we also have to acknowledge that just like a handful of people will ever be able to participate in a process.
And do you think that crowd loans are actually a useful tool for that, like in regards to both token distribution and both to like, you know, basically making people care more about the chain itself and about the project itself, because they have made some significant investment, their tokens are vested, so actually they have to wait, until all of them are unlocked, so they are like more motivated to watch over the chain and to see what's happening over there, and maybe also participate in governance too.
I think that's actually a really good idea to have it that way set up. So also that those vested tokens that you can't actually spend can still be used in governance. So that idea is actually really pushing forward that users actually care about their chain and that they care about their investment. So it is actually a selfish action then to participate in the governance, because you have stake in it, And I think that's not the worst thing. Also with crowd loans, that really small contributions are possible, and you can have big gains of that. And I think that's a really good process actually to distribute your initial tokens. So I think it's much better than like going to like 1 or 2 VCs and collect money for a company.
Yeah. All right. Thanks. So I suppose we are a bit overdue right now, so one last question.
Say a little bit. So for example, on Ethereum, a lot of people are using good incentivizing model as, for example, when people are donating on Gitcoin grants, some projects are using that as like a reward model. So when you donate to our Gitcoin grant, then eventually we can reward you with some tokens.
Sounds nice, actually. Yeah. All right. So last question. So, and we've already touched the topic. There are like emerging layer 2s on Ethereum, and maybe unlike Annette, I don't think we are there yet. I don't think it's like really easy to build your custom layer 2 right now. Especially if you compare it to Substrate, which is a tool for building parachains.
Just look at what Solana did. They had the great marketing. They put so much money into their events, into their branding, as well as Polygon.
Yeah, but that's what the question, it wasn't about it. Actually, it was about it, like, if you guys see actually layer 2s on Ethereum as a competition to Polkadot, because in the end, in a couple of years, it can actually become really easy to make your layer 2 on Ethereum. It can be actually compared to Substrate, within a few years. So what will be the main selling point of Polkadot then, when we are there with Ethereum, and when you can use something like a Starknet actually, to deploy your own layer 2, and that can be easily customizable to your own needs. So what will be with Polkadot then?
So my take on that is Polkadot is just a fresher system. So Ethereum carries a lot of the old code, of the technical debt that every software project basically accumulates, and it carries it on. And for example, you only have like the EVM. So that's a limiting factor. Yes, you can write and invent more high-level languages which compile down to EVM. But for example, in Polkadot, we could basically break out of that, and we could say, we did it. Let's just add a new layer for smart contracts, for example, based on WASM, for example. And to add this functionality, for example, to the current version of Ethereum, I just don't see it. It won't happen. So there are decisions made within the protocol which come from the early days, but those decisions were made and they are written in stone because it's like on the chain. You just can't change the protocol. And that's why I'm really in favor for Polkadot, because it was written with all the experiences from Ethereum in mind, and this basically makes it, from my point of view, as a successor of it. So, and that's like my main argument for rather using Polkadot. So, because it's just the fresher system.
By the way, this panel was not supposed to be like a fight between Ethereum and Polkadot. It was just
now
like,
definitely.
They're just to like bring more fire into the pot that we are boiling, here.
No, I don't want to bash Ethereum in any way, really.
I mean, like,
there's so much very important groundwork which was done by the Ethereum people. And the ecosystem is also much more mature than our ecosystem. There's so much that can be learned from Ethereum. And I mean, also just look at the volume. Yeah, so we don't have to argue about that. And please don't be bashed. I just wanted to make my point that yeah, Polkadot is really like implemented as a successor, also just from the history point. And that's all I wanted to say. No bashing on Ethereum.
That was kind of the question, because I think the advantage kind of is on the Ethereum side, right? Because the Ethereum is still developing, you know, and technology is getting better. Like, I mean, we got ZK Snarks, you know, ZK Starks are coming, you know, there's Starknet. You can actually have already your own layer 2s like StarkX.
Optimism.
Which used to be, yeah, but Optimism is like still EVM, but I'm talking.
Zero knowledge.
Yeah. I said ZK Snarks, yeah. So what I mean is actually Ethereum is like getting there, you know, to being able to roll up, you know, any kind of layer 2 connected to Ethereum that can do like really anything you want, and you can do it now. But I would say it's like really difficult, unlike on Polkadot. But it won't be that way, you know.
Ethereum
in
is like
years.
expanding itself, and it's like experimenting, and there is so much development happening in Ethereum these days. And we are just like trying to like test out different ways how and like see what can work out. And I feel like we, especially after the merge, Ethereum has evolved into very experimental stage where we are just trying to figure it out, like which system. Barry, you're cool.
Seems like we are already late.
Seems like Barry is just like the most talkative human, like fluff here. But yeah, what I wanted to say is basically, after the merge, I feel like we are in the experimental stage with Ethereum again, and we are just trying to figure out like which either like layer 2 or which kind of solution is the one that is the most attractive to developers, users. Like on which kind of system or which kind of L2 we can make sure that we get enough traction, we get enough volume, will be enough, like the most interoperable, will be most secure. So I feel like we are just trying to like figure that out, and especially with so much drama going on lately, and also bear market, it's kind of like hard to stay focused, and kudos to all developers these days, because focusing yourself on building right now, it's extremely hard. And I appreciate every single one of you who is developer and who is building and who is not giving up on their skills and their projects. So thank you.
Yeah, all right. Yeah. Okay, so I suppose that's it. So thanks a lot, guys, for joining the panel, and thanks to our audience for having the patience with us. And so hopefully it wasn't, you know, too much boring for you, and hope to see you on the after party. Looking forward to that. So thank you again, guys, and see you there.
Thank you.
Thank you.
Bounty, for which we're very appreciate. And yeah, now it's time for the after party. So one more thing we would like to do before you all go separate ways, which is like a group photo, you know, like in high school or something. So we would invite you all like on a stage, including the organizers, and we're gonna just do one for the road. Let's put it that way.
Okay, thank you so much to all the organizers who throw this conference. And thank you so much to all volunteers that managed to put up this conference. And it's awesome for everybody to come to Brno because it's such a little town. And I feel like it's very cool to have people come to Brno, although you guys are from all different countries, all different cities, living their own lives. And it's very awesome that we all met here in Brno, which is such a little city. And yeah, thank you. Yeah, it was awesome Polkadot conference, and actually as somebody who doesn't work in a Polkadot ecosystem, I feel pretty welcome. Thank you. So let's come here. We are going to take a picture, I think. Come.
I'm tall.
Yeah, it's okay. Yeah, I'm just like looking at you. Počkej, pojď do středu. Berry, kde Berry? No, Berry, kde je Berry? Berry. Polkadot. Should we make like a pose?